shipbuilding through modern shipbuilding. The organizers are Pondicherry University and St. Petersburg State Marine Technical University. This webinar is performed under the support of Ministry of Industry and Trade of Russian Federation and ELCOM Group, India, in the partnership with the International Exhibition NEVA. We start our first day in compliance. There is a relevant link to join us. Mr. Rozdestinsky is representing the Marine University, and Mr. Raju, professor, is representing the Pondicherry University. Audita Banerjee is scientific assistant of Pondicherry University, and now we would like to give the floor for welcoming speech. Embassy of Russian Federation in India. We will try to connect. Nikolai Rishatovich Kudashev is extraordinary and plenipotentiary ambassador of Russian Federation in the Republic of India. So I would like to give the floor to the trade representative of Russian Federation in the Republic of India, Rybus Alexander Leonidovich. Alexander Leonidovich, thank you. Good morning to all the participants of the webinar. I welcome everyone on behalf of trade representative. I was commissioned by the ambassador of Russian Federation in the Republic of India. I would like to read a welcoming speech of his dear participants of the webinar Russian India on shipbuilding. I'm glad on behalf of the Embassy of Russian Federation in India to welcome Indo-Russian online conference, Nation Building Through Modern Shipbuilding. The name itself is appealing because in our countries, shipbuilding is the system-generating sector. Judging from the agenda, leading scientific centers, design bureaus, and shipbuilding companies, as well as universities, are involved in this webinar. The importance of interaction between such states as India and Russia in the sphere of shipbuilding, ship repair, and shipping is growing. I should highlight that irrespective of the pandemic, the economics of our countries are recovering in the fast way, and that proves the possibility to improve the trade and economic cooperation, especially in the shipbuilding sphere. The volume of import today is exceeding 40% comparing to the first half of the 2020. And also one of the components of the economic growth is the shipbuilding, though it has been reduced, and Russian companies, the leaders in the creation of the building of the floating power units working on the liquefied natural gas and nuclear energy, have great prospects to enter the Indian market. I would also like to highlight the growth in the sphere of education and the possibility of creation of joint educational programs in the sphere of shipbuilding. It is truly important to train the young specialists, and it becomes the key factor for future successful cooperation. And of course, there is a special session dedicated to the fourth generation of the economy that we are entering right now. The webinar is arranged just before the meeting of our countries, states of our countries that was planned. So I think this event is happening just in the due time. I wish the participants from the side of India and Russia a very successful work during this webinar. Extraordinary and plenipotentiary ambassador, Mr. Kudashev, if you don't mind, I would like to say a few words from me personally, using this chance, being here as a trade representative of Russian Federation in India, interested highly in the development of cooperation, especially in the sphere of high technologies and energy, and as a member of the Council on the fleet support. I would like to say that Russia and India have multi-year successful experience of cooperation in the sphere of naval shipbuilding. And so I would like to focus, to inspire you to focus on the commercial vessels building. And Make in India is one of the program, Marine Strategy 2030, Sagalmara, Vitas programs is a clear message to our shipbuilding that trading and economic cooperation can go up to the new high quality level in the sphere of commercial shipbuilding in order to use the reserves of economic growth. During recent 2 years, we are actively supporting these activities. Russian companies are in dialogue with Indian companies on the issues of cooperation in the sphere of shipbuilding. More and more Russian companies become interested in sharing the experience and competences in the designing of ships and building new fleet. To our mind, to achieve this goal, we need to focus mainly on creation of joint production companies, service companies on the level of transfer of technologies in the sphere of services, training of personnel, and development of joint scientific and research activities. Today, I think this event will help us to get the progress in this direction. And I would like to add that the trade representative of Russian Federation in India is always ready to support to any Indian and Russian company in order to achieve a breakthrough in the main directions of bilateral economic cooperation in the sphere of shipbuilding. Thank you for your attention, and I wish you all success in your work. Thank you very much, Alexander Leonidovich, and we wish you good luck and success. Thank you. There is a welcoming speech from the chairman of the board of directors of the United Shipbuilding Corporation, Georgy Sergeyevich Poltavchenko. If you don't mind, I will read it out. It's addressed to Mr. Turichinov, the director of the Marine University. Dear Gleb Andreevich, dear friends, I sincerely welcome the participants of the webinar between Russia and India in the shipbuilding. It's a very important event in the sphere of arrangement of business contacts between our countries. The issues of training of highly qualified engineers in the sphere of shipbuilding, exchange of experience and new scientific ideas is very important. Russian Federation is interested in continuation of the efficient dialogue with our Indian partners in the field of shipbuilding and ship repair. This webinar will definitely allow us to get the new information, exchange the ideas and the projects, and will promote bilateral economic connections. I wish you efficient discussions and work to achieve the goal of development of cooperation between Russia and India. The chairman of board of directors of USC, Mr. Poltavchenko. Thank you. I would like to show all the co-chairman and chairman of our sessions today. Their CVs will be presented during their speeches. About 16 people are here, 8 famous people from India and 8 from Russian Federation. As per our agenda, let me move on to the welcoming word of the Vice Admiral Zheshpand. I would like to give the floor to Indian side to get the commands, and I think there is a moderator here. Let me announce a welcoming word of Vice Admiral Mr. Deshpande. I would like to say a few words about his biography, which is truly important. He started his career in Navy in 1969, participated in different operations on board Indian ships, and he has a great experience of working with helicopters, rotary wing aircrafts. He was involved in the acquisition and repair of different aircrafts. In his career in fleet, which is 38 years, he held a number of distinguished appointments. He was the air engineer of Air Squadron number 561. He was head of production department at Naval Aircraft Yard, Kochi. He also worked as a head of the base maintenance facility in Guam. He worked as a Commodore superintendent in the dockyard in Kochi, and he was also involved in the HR policy, assigned as a material director of naval air materials. He also was a flag officer, admiral, the chief staff officer, technical at both the Western as well as the Eastern Naval Command headquarters. He has graduated from Marine Ammunition College and National College of Defense. And he was awarded with a number of medals, Vishisht Seva Medal and Vishisht Seva Medal VSM, as well as AVSM for his meritorious service. Please, Vice Admiral Deshpande.
У нас переводчики работают, нет? Да. А вот он здесь есть он, да?
Should I start off?
Yeah, sure. Yes.
Yes, please.
Okay. Thank you very much for that introduction, ma'am. It is a great pleasure for me to join this webinar. Believe it or not, but at my age, this is the first webinar that I'm attending ever in my life. So there will be a few errors I'll make because I don't know what a webinar is like. I am more used to getting into a hall or standing in front of a mic or talking to people whom I can see. So I'll be a little disjointed in my approach to this webinar. But first of all, I would like to greet my Russian friends with whom I've had a very, very long and very, very fruitful cooperation for a number of not just years, but decades. Dobre utro, gospoda. I'm very happy to be with you in this webinar, to participate in this webinar. And it is indeed a rare honor done to me to be the co-chair of one of these sessions. As Madam said, I spent a fair amount of my time in naval aviation, going back and forth between ships and aircraft. But towards the end of my career, it was ships and submarines, and that's it. And some of it was spent also in planning, getting new ships designed and getting them constructed in various shipyards, be it in Sevmarsh, as far as Sevmarsh in the right north of Russia, to Kaliningrad, to St. Petersburg, to La Spezia, everywhere I went. And what struck me was that shipbuilding, whether it is warship building or whether it is merchant shipbuilding, it's a very, very unique technology and very unique art, which has engaged the minds of human beings. When it's beyond history. It is time immemorial that people have been going to sea. And they have evolved and evolved and evolved into such a beautiful technology today. And this is what enables us to really interact with each other at various levels. So all those years of experience, I shall try, and with that experience, I shall try and do some justice to this webinar. Coming to this webinar, I think the timing is very, very appropriate. And the reason is that today's world, it's a very peculiar world. The geopolitical scene, as well as the scene in which we find ourselves as far as the environment is concerned, both are impacting very, very heavily on shipbuilding, ship construction, ship design. Every single aspect of going out to sea and going away from your country and going into another land, all these factors of geopolitics, of the environmental protection and security issues, they have had a great impact on our shipbuilding technologies. Traditionally in India, when the British were ruling us, although they were a great seagoing nation, just as Russians have been very great seafaring nation, but they built their wooden hull ships in India because we had some of the best material then. Today, nobody builds big ships out of wood. Materials have changed, design technologies have changed, but the medium has not changed at all. The medium still remains the sea, the ocean, the waves, the salt atmosphere, and the ability to navigate across all these safely, economically, and without damaging the environment. And these are the watchwords that I've always given to my people, that when you look at going to sea, and being at sea, I've been a senior engineer of a ship, I've traveled in long distances on ships and so on. Safety is very important. You cannot endanger life of people, you cannot endanger the cargo which you're carrying, you cannot endanger the sailors and the officers who are fighting the war for you. They have to be safe. And sea is a very safe person, but very unforgiving if you have made mistakes. The sea does not forgive you if you make mistakes. So safety in your design, in your construction, is of paramount importance. Modern shipbuilding, of course, we have stopped using wooden hulls, we have stopped using the sails, we have got extraordinarily good quality steels, we have got extraordinarily good quality designers, we have got manufacturing technologies and methods which make sure that whatever we put out at sea is safe, and yet we do have accidents. You do have fires at sea. You do have ships which collide with each other and create a problem. So each of these aspects, the designer has to be very careful in designing for making sure that none of these happen. Modern shipbuilding also, unlike modern other technologies where people sit in nice air-conditioned offices and try to control finances, they try to control the production and so on, shipbuilding requires hard work. Engineers have to stand on the dock, they have to stand on the dry dock, they have to stand in the building yards. It is tough work, but it is the tough people who can take tough jobs. And I've seen shipbuilders all over, particularly in Russia. I've seen in Sevmash, I've seen in Zvezdochka, I've seen them in the northern shipyards. They're tough people. They don't walk from hard work. They are willing to do the hard work and they produce the best quality ships wherever they are. And it's the same in India. I've seen people in Mazgaon Dockyard, I've seen them in Garden Reach, I've seen them in Cochin Shipyard and so on. You need an attitude that we shall produce design and produce the best ships that ever put out to sea. My association through the Navy with the Russians has been extraordinarily fruitful. I've always enjoyed interacting with the Russians. They have great technologies. In majority of the items, they have reached great heights, and I wish them that they will always continue to rise to greater heights. And therefore, this particular seminar is one thing that I hope, and I'm sure that it will happen, that it will bring the Russian side and the Indian side even closer together. We have always been very close. I must have gone to Russia about 25 times in my tenure in the Navy. And at each one of those occasions, I've enjoyed the camaraderie and the partnership with the Russians. And I now pass this on to the next generation and I say, make friends with Russians. And I say to my Russian friends, we come with druzhba and for cooperation. So this particular webinar, which has been jointly hosted by the Pondicherry University and the SMTU, it's timely, I think, for us to strengthen, renew our bonds, exchange our ideas, exchange our thoughts. For example, with great technologies for shipbuilding, I found a few areas where the Russian side was not up to where we are. For example, all the wiring systems, the best wires are produced here. The Russian side, unfortunately, they don't produce that. So this is where our cooperation, the steels, for example, we used to get the best steels from Russia. Now, of course, we have started building with our own steels. There are gas turbines. There are so many areas in which we can help each other. And 1 + 1 here doesn't become 2. It becomes 11 or 100 or whatever you want to make it. One is Russia, one is India. And if you must put these 1 and 1 together. And through such webinars, we can interact. COVID-19 doesn't matter. We can still get together. We can talk to each other. We can interact with each other and profit from each other's experience and make sure that our friendship will continue to grow. One of the items would be the shipbuilding. Of course, there are many items in which Russia and India interact, but ship construction, ship design, and ship repair are the areas which offer a great potential for us to go even more than where we are today. With these few opening remarks, I would like to wish this webinar all the success. It will be indeed very interesting for me to continue participation in these 2 days. I look forward to listening to my Russian friends as well as my Indian counterparts here. Through this interaction, even in my old age, I hope to learn something new. Thank you very much and look forward to a great webinar for the next 2 days.
Спасибо, адмирал, за замечательные слова.
Thank you very much. Thank you, Admiral, for your great words. We continue. And I would like to give the floor.
Хочу предоставить
I
слово
would like to give the floor to the director of St. Petersburg State Maritime University, Professor Gleb Turichin. I will tell a few words about him. He graduated from the Russian Polytechnical University, today it's St. Petersburg University. The specialization was physics of metals, and here defended the PhD dissertation and doctor dissertation in 2000. From 2001, he was the professor at the Department of Theory and Technology of Welding. From 2001, professor and deputy head of the Department of Welding and Laser Technologies. In 2004-2007, he was deputy director of the Institute of Laser and Welding Technologies. From 2009, he was the Dean of the Faculty of Technology of Material Research. From 2016 until present time, Professor Turichin is rector of our university, St. Petersburg State Marine Technical University. He works in the field of theoretical research, modeling, and technology development of beam processing of materials with beam processing, and he is one of the leading experts in this area, both in Russia and abroad. In 2019, Professor Turichin became candidate for the title of corresponding member of the Russian Academy of Science, Division of Chemistry and Material Science. He is a laureate of the prize of the Russian government for development of science and education system, of training of high qualified personnel in the field of laser technology, of processing of materials. He is a multiple winner of St. Petersburg government competition for the best innovative development. He delivers the main special course, Theoretical Basics of Processing Materials by means of concentrated energy flows. He also has about 200 scientific works, including 3 monographs. He is awarded by the Order for Merit to the Fatherland and medals of the Security Council of the Russian Federation. So Professor Turichin develops our university both in Russia and abroad. So I give him the floor. Thank you, Mr. Rождественский. Good morning, dear colleagues. I'm very happy to welcome you here, all the participants of our webinar. India and Indian science, Indian industry, they are very interesting and long-term partners of our university. We take into account just great size of the Indian market. We hope that our collaboration has no limits for further development. Especially important is that today we have a webinar devoted to shipbuilding industry, when shipbuilding all over the world is at the stage of very deep technical and technological changes. It is related to the fact that the fourth industrial revolution came today to the shipping industry. Traditionally, our industry is one of the most conservative areas. However, we cannot participate in technological changes and transformations. And those who will not be able to comply with the speed of changes, they will have to quit the market. Our country in this area is very seriously supporting the development of shipbuilding industry. Another factor that brings very sharp changes in our life, it's the digitalization, the transition to small-scale staff or without staff vessels, and it is a wide collaboration. A vessel as an object becomes a participant of multi-agent system without so many people, but with online connection with probes, and it becomes autonomous or half-autonomous object. Another driver of changes is related to new materials that come to shipbuilding. For today, of course, usually we use metal shipbuilding, but more and more composite metals or composites are used, and it means not only new consuming factors of ships, but it also means that shipbuilding will influence other areas of industry, because our industry is of high level of integration. Under there are machinery, metallurgy, chemists, electronics are below us. So the changes in shipbuildings touches all other industries, and all these changes in shipbuildings change the whole system of preparation of employees. For new shipbuilding, we need new employees and new experts. And this is the key, the heart of our activity. And we would like to widen our activity and maybe to build new collaborations with Indian colleagues in terms of preparation of specialists, as well as shipbuilding enterprises as our partners. And we would also like to collaborate with industrial. Unfortunately, I don't hear the speaker, so I cannot interpret.
Hello, 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 hello.
Professor Kirill? Professor Kirill? Udita, is there any problem there?
No, sir, I can hear, but the screen is like it's on hold. Nobody's speaking.
Unfortunately, the Russian side is not here. I can't hear the sound, so I cannot translate.
It looks like
Okay.
here.
No, sir, actually, I think that the sir who was speaking has lost connectivity. So you
Yes,
can
yes.
ask.
But
Yes,
but
sir.
I can listen to you. Yes, yes.
Yes, sir.
Udita Patil, my video has been shut by the system administrator.
Okay.
The camera.
Yes, sir. Yes, sir, but you're audible.
I know, but the camera is not on. It says the host has shut it.
I think then, sir, from that side, actually, they are controlling the program.
Okay.
So they are working on technical issues, and it will take maybe a few more seconds, and they will start.
Okay. Hello. Hello.
No. Do you hear us, gentlemen and ladies?
Yes, sir. Yes, Professor Kirill.
Okay. So now I'd like to call upon Udita Banerjee, who is our Master of Ceremonies, in order that she could introduce our next speaker from India, and this is Vice Chancellor.
Yes, sir. Very
И будет говорить церемонимейстер. Master of Ceremonies, Udita Banerjee.
Yes, ma'am. Yes, sir. Sorry. Pardon, sir. Should I go ahead?
Yes, you can.
Yes.
Okay, sir. Good afternoon. And our next speaker is Mr. Jayant Patil. And Mr. Jayant Patil is a whole-time director and senior executive vice president for L&T's defense business and new age smart technology businesses and member of the board of L&T. He is an alumnus of IIT Mumbai. He is also the chairman of the board of directors of L&T MBDA Missile Systems Limited. He is president of Society of Indian Defense Manufacturers. He is a member of the board of InSpace. He is a member of CII National Committee, chairs CII Committee on Strategic Manufacturing. He is founder chairperson of Indian Space Association. He also serves on the PMA India Managing Committee and has been conferred with PMA India Honorary Fellowship. Earlier, he served as member of Steering Committee, National Executive Committee, and Chairman Defense and Aerospace Committee of FICCI. I ask Mr. Jayant Patil, sir, to please give your greetings. Sir, over to you.
Good morning. Till such time the host turns our videos on, you have to hear me blind. And it's a pleasure to be part of this webinar, specifically talking about technologies. And what better to have this kind of a webinar when we have a long-term trusted partners from Russia and from India talking in a webinar together. When I start looking at shipbuilding, India has an amazing history in shipbuilding, and we know 5,000 years back, India was doing shipbuilding. And of course, those days, we remember that India was one of the lead nations in terms of building ships. As Admiral Deshpande very rightly brought out, ships those days, right up to the 18th century, happened to be built in wood of a very special quality, and that's something that was abundant in India. Of course, the turn of times and changes in technologies meant wood was no longer being used in shipbuilding, and that's the time things started changing. Of course, India was at that point in time being ruled by the British, and things started changing thereafter. Indian Navy, as we have seen it from the industry perspective, started truly making a difference to make things within the country. Of course, those years of 1960s, 70s, 80s, we have seen enormous amount of support to Indian Navy and the shipbuilding coming from the Russian partners. At the same time, beyond those periods, when we start looking at having created a design bureau of their own, the major system integration kind of special divisions within the Navy is directorates and the professional directorates for every major equipment and systems by classification of what goes into a ship. India actually started building in naval shipbuilding a very, very special prowess. Technologies kept evolving, and with the computerization, we now see ships which are essentially completely being built, not just in very special steels, but things that do not really need individual compartments to be manned and compartments to be actually operating different parts of the ship. And it's an integrated kind of controls which have started coming in. So it's as good as saying you sit in a cockpit called bridge, and of course from there, anything and everything that happens within the ships start getting controlled. Today, India designs and builds almost every class of vessels. The capital nature of ships obviously are designed by the Indian Navy themselves, and that includes the frigates, the destroyers, those ASW corvettes that have been realized, also the aircraft carrier, while anything below those classes is designed and built by all the shipyards that are existing within the country. When we start talking of large number of vessels which these shipyards are building, other than the capital vessels, which essentially tend to be very, very complex, very large, but a fewer in number, the larger number of ships today are getting designed and built in every possible shipyard in the country. And of course, there are a few who have started making a difference. Larsen Toubro took a decision as major kind of equipment and system builder for the Navy, which started happening in the 80s. Although right during the British era, Larsen Toubro used to be involved by the British in the naval ship repairs as well as the commercial ship repairs. But in the independence era, those mid-80s onwards, that we were truly building indigenously various equipment and systems, and a range of them to the absolutely the latest and the most state-of-the-art equipment and systems, including weapons, engineering equipment, life support systems, varieties of sensors. All this has started happening in India literally 30-35 years back. Post opening up of the defense sector for private industry, which happened in India on just about 2001, and licensing began in 2002, we at Larsen Toubro decided to enter into shipbuilding. And this shipbuilding entry was marked first by creation of a design house. We didn't start bidding for ships and after winning to do a design, but we first established a design department, and based on our own in-house designs, started bidding for vessels. Over last little more than a decade, since the day the design bureau was opened up, it's about 15 years now, but we started receiving our first of the contracts from 2010, and over about 11 years, we are someone who's designed and delivered 67 vessels, helping yet another country to build another 7 of them. And of course, every vessel that we have delivered has been designed and engineered within the country. Now, when you start doing something of this kind in this just about a 1 decade kind of a period, calls for truly use of technology. And this is one domain where we believe at Larsen & Toubro, for Indian Navy, Coast Guard, we started making a huge difference. Since the theme of the seminar talks about the technologies, today it's not just about the basic naval shipbuilding that we are talking about, the methods to do the same in terms of huge modularization, enormous amount of digitalization that gets used in the design, that has started becoming important. The terms of Industry 4.0 used to be talked in the mass manufacturing industry, where an equipment or a small component and a subsystem is designed in the design office onto a computers. And that's what directly sort of machines or produces those parts directly on shop floor. But at L&T, we essentially made sure that the same Industry 4.0 methods and technologies started getting utilized to build warships. Now, this is essentially where the entire ship, what you're trying to do from the design office, starts controlling every machine on the shop floors, including the plate cutting, to thereafter pipe cutting and the cable cutting. So no longer is something one would want to do that individually run a pipe and then decide what length you require, or individually run a cable, pull a cable and then cut it to decide where it needs to be terminated. Now, this is something which can be pre-decided, pre-cut and pre-fitted, making more and more of cables, especially within the compartments in the form of harnesses, makes an enormous amount of difference and gains speed. With such methodologies, which obviously I'm not today in a position to be showing some of these pictures, but when one starts seeing some of these pictures in terms of the fitting out, we're proud to have achieved about 85% fitting out of a vessel before a vessel is launched. So we are talking of a ship in terms of completion, typically 85-90% complete, and then you launch it. And thereafter, obviously, only the balance fitting out, more of the human-related fitting out is what remains balanced. Also for trials, you need the ship to be in water, and those are the activities that essentially are done after the launch happens. Now, that's essentially where it's a game changer in terms of technologies to be able to do a shipbuilding with Industry 4.0 methods, obviously fully integrated with the project management tools, with the ERP systems, so that the entire cost of a program, entire bill of material of a ship is not something which can easily be controlled on a bill of material, because there are tens and tens of thousands of physical items and equipment which one needs to be buying for fitting into a ship. And that's essentially where the modern technologies in terms of availability of powerful softwares and the computers, and the entire design being from 3D domain, to be able to then do it into a 2D domain in the workshops, is where the computers play an enormous amount of role. This is precisely what also enables that the entire vessel, in terms of every function that the warship is supposed to be performing, can be centralized in the form of an overall information management system. And that's essentially where an integrated bridge or integrated platform management system come into existence. And those are something which are happening in India today on ships which are relatively 1500, 2000 ton class. Having an IPMS onto 100-ton class ship is unheard, but that's what is happening in India. And that's essentially where you enormously gain in terms of speed of production, in terms of making the ships much, much faster. So this is one extreme game changer, which I thought is of relevance when we are talking of technologies. The physical fit out, when you start doing a modular construction, which obviously the technology under 4.0 allows that to be done, and you produce typically about 70 to 80% fitting out right at the block levels before the blocks are integrated, and then from smaller compartments to blocks to super blocks and to those mega blocks that you finally assemble into ships. That's something which today can be seen right in India. And this is essentially where, through sheer use of technology, one can do shipbuilding far more efficiently. The days are today around when you can build a complex vessel in 18 to 24 months. It's not unlike the earlier days when one would physically take that much of time to build a hull, launch the hull, and then do the fitting out for next 3 to 4 years. So this is what essentially is today happening right in the country. And I think it's of relevance to put on record that this is what is the future. This is where it is moving. And this is not only in terms of surface warships, it's also happening on the underwater vessels. The future obviously holds enormous amount of promise in terms of doing more and more. And India is obviously extremely focused on that Make in India. And with Make in India and what we call as Atmanirbhar, literally meaning self-reliance, the self-reliance obviously means that we are open for doing things ourselves.
Это означает, что мы открыты для партнерства, особенно с теми людьми, которых мы знаем, которым мы доверяем, и с которыми работаем и сотрудничаем уже на протяжении многих десятилетий. Мы считаем, что у нас действительно восхитительные взаимоотношения с российской стороной, достаточно прекрасные для того, чтобы осуществлять успешное сотрудничество. БРАМОС — это система прекрасной организации партнерства между Россией и Индией. С точки зрения судостроения, особенно с точки зрения слияния технологий и опыта, мы можем действительно создать еще более успешные продукты. И я желаю этому семинару различных возможностей, которые появятся в результате работы этого семинара, создать новые перспективы сотрудничества. И мы знаем, что наше сотрудничество длится уже на протяжении многих лет и будет продолжаться еще достаточно долго. Так что желаю успехов этому вебинару. Спасибо за то, что пригласили меня.
Ничего страшного. Так, уважаемые коллеги.
Dear colleagues, let me announce next speaker, Joint Secretary of Defense Production. I would like to give the floor to the Master of Ceremonies to announce. Audit, please.
Yes, sir. Our next speaker is Professor S. Balakrishnan, and he is our officiating VC, as our VC, Professor Gurmeet Singh, is not able to join the event due to unavoidable circumstances. So Professor S. Balakrishnan, he would be the next, he is the officiating VC. Professor Balakrishnan obtained his BSc and MSc degrees in geology from the University of Madras, Chennai, and his doctoral degree from Jawaharlal Nehru University, New Delhi. He commenced his research career as a postdoctoral fellow in the Department of Earth and Space Sciences, State University of New York at Stony Brook, USA. He started his academic career as a lecturer at the Department of Earth Sciences, IIT Roorkee. He joined as Professor of Earth Sciences, Pondicherry University in 1997. I request Professor Balakrishnan to please take the stage. Sir, over to you.
Yeah. Good morning to all the dignitaries. It's my pleasure to be part of this inaugural function of the Indo-Russia webinar on nation building through shipbuilding. Particularly, I'm honored to be sharing the dais with Vice Admiral Deshpande and Rector of St. Petersburg Marine Technical University, Professor Gleb Turishan, and also with other dignitaries such as Professor Mr. Jayant Patil and Professor Subramaniam Raju. And I congratulate Professor Subramaniam Raju for organizing this webinar. which is a timely one, where India is poised to launch many ships, particularly the naval ships, in the coming decades, and the technological advances also need to be made in various fronts, as rightly pointed out by my previous speakers, including Vice Admiral Deshpande and the St. Petersburg Marine University Rector, that the advanced composite materials and design aspects have to be taken into consideration. So in this regard, the higher educational institutions such as Pondicherry University, which is a central university, also can play a very important role. We also have advanced, physics, nanomaterial, and other, laboratories where certain aspects of the, material, design are, finding certain composite material which is of relevant, which has relevant properties to match the requirements of the Navy, naval shipbuilding. All these things can be taken up at the university. The university, our Pondicherry University, has already taken up several research projects in collaboration with agencies such as atomic industry, atomic power industries, as well as space industry. So similarly, we can have a collaboration with shipbuilding industries to look into certain specific aspects where the university can provide the scientific input, scientific and technological input in the form of research, targeted research, addressing the problems oriented to the shipbuilding. So as all of us know, one of the major problems is also corrosion. Developing suitable paints and other materials that resist corrosion. Here also the universities, particularly the departments of chemistry, green energy technology, and nanoscience, they can also play a very important role in developing materials that will enhance the shipbuilding capacities of the both nations, India and Russia. So here, with this, I offer the services of Pondicherry University, that the shipbuilding industry, the Navy, and the other organizations involved can take note of the capabilities of the university, particularly Pondicherry University, in doing certain applied research, which will facilitate better materials and better, better ships overall. Okay. With these few words, I thank you for inviting me, and I am happy to be part of the inaugural ceremony. Thank you very much.
Большое спасибо, коллеги.
Thank you so much, dear colleagues. I would like to give the floor to Valentin Valentinovich Romanov, who is the Executive Director of Indian Group of Companies, Sun. Thank you. Dear colleagues, good morning. Dear colleagues and friends, as the representative of Indian company, I could have spoken English, but as far as I understood, the protocol does not allow me to do that, so I will continue speaking Russian. It's a big honor for me to participate in this event, especially as it was emphasized just 1 week before the meeting of the representatives of our two countries, the President Mr. Putin and Prime Minister Narendra Modi, Prime Minister of India. I think that is highlighting the importance of the topics that we are touching today. It was already mentioned. Many topics were already described by my colleagues, so I wouldn't like to waste the time, but as the echo of the previous speakers, I would like to emphasize and highlight that today the shipbuilding sector, especially in the 21st century, is the driver of national economics, in Russia and India is the sector that is promoting the development of industry, technological progress, and is based on the latest achievements of science and technology. In this regard, our company, which is leading the business cooperation with Russian Federation within more than 60 years, it's a big honor for us that ELCOM Group, one of the affiliated structures, is contributing in the cooperation in the sphere of shipbuilding as a company specializing in electronics and special communication systems. I would like to wish all the participants and speakers to have efficient discussions today, and especially to thank two universities, a famous St. Petersburg Marine Technical University and famous university in Cochin that has contributed a lot together with our colleagues from St. Petersburg to arrange this event, these 2 days, today and tomorrow. And it's especially important because this is giving us a hope that a young generation of both countries will continue that interaction that has been built within decades in the marine sphere, in the shipbuilding sphere, and the joining sectors. And to finalize, I would like to mention one observation from my side. Colleagues in India, unfortunately, do not see what's happening now outside. It is snowing in St. Petersburg right now. Today, the forecast promised us to have -6, -7. It is +22 approximately in Delhi now, and I hope that within this discussion, these temperatures will equalize, and we here will probably warm up a little bit in the course of our discussions. Good luck to everyone and all the success. Thank you very much, and we are very lucky that you are here in St. Petersburg. And we wish you all the success and to promote our cooperation with India. Thank you very much. There is no sound. The translation is not possible, unfortunately. No sound.
Professor Kirill?
Some technical issues. There is no sound.
Hello? Hello?
Hello.
Yes, yes. Hello.
Hello, is Mr. Raju?
Yes, yes, speaking.
This is Rishikesh Narasimhan. You can't see my video, but I'm on the audio, and I'll put the video on at the right time.
Yes, sir. Yes, sir. Good to talk to you, sir.
Just a second.
Sir. Yes, sir.
So is that okay?
Yes,
and
sir.
Okay, yesterday I had tried out my share screen and it worked okay.
Sir.
So I'm standby. It's 12:30.
Yeah, but yeah. There's some problems. I think it's disconnected from the Russian side.
Okay.
So just yeah. So just we have to get the message from them, sir. Just we are waiting for
Yes.
from their side.
Can I have your mobile number just in case something goes wrong?
Yes, sir. 9500
9500
2877
2877
50, sir.
50. And I will give you my mobile also.
Yes, sir. Please, sir.
It's 99625
Sir.
62263.
62263. Oh, fine. 2 4.
So in case of a problem, you can just say,
Yes,
give me a WhatsApp.
Yes, sir. The same number we have access to WhatsApp, sir.
Yes. Everything is there.
Oh,
And yeah.
Fine.
So I'm the fourth speaker, and so I'm going to mute it until my turn comes. Or how do we ping so that the time? Okay. Anyway, we'll get to know when the third speaker gets over. Then I will show my video.
So yes, I think they have come back.
Colleagues, do you hear us now? I think we have restored the sound. Thank you.
Anastasia, NEVA Exhibition, famous international marine exhibition, NEVA representative. Probably temperature mode resulted in some problems with the connection. Unfortunately, we couldn't overcome this. Good morning, dear colleagues, dear friends. On behalf of the NEVA International Company, on behalf of this international shipbuilding exhibition NEVA, I'm glad to welcome you at this webinar today, at this conference, Indo-Russian conference that is called Construction Nation Building Through Shipbuilding. For us as the largest shipbuilding exhibition, it's a big honor to be a co-organizer of such an event. And I would like to wish all the success, new connections, interesting dialogue to all participants of today's conference. Thank you for your presence. Thank you, Anastasia. Thank you very much. Dear colleagues, we are finalizing this session, welcoming speeches, plenary speeches, and we move on to the first session, which is called Modern Shipbuilding. Co-chairman of this session is the honorary president of Scientific Technical Society, named after Krylov, hero of Russia, Vladimir, honorary citizen of St. Petersburg, Vladimir Alexandrov.
Professor Kirill. Professor Kirill. We have Rear Admiral Pritam Lal.
Sorry. Okay. Так, заключительное слово.
I apologize. We would like to give a welcoming speech to Jayant Patil.
Не включается. Сейчас скрин. Так, Вадим, что-то я не могу. Сейчас скрин включаю. И он у него докладчика. Mr. Jayant Patil, switch on your mic, please.
So, Professor.
Sorry. This is Admiral Deshpande. Yes, Admiral Deshpande. This was from previous version of the program. Vice Admiral Deshpande.
Okay, I'm here. This is Vice Admiral
Share screen.
speaking, and we start the session. I presume that you're referring to the session on modern shipbuilding, which we are supposed to commence now. Am I right?
Куда нажимать? Сейчас. Сейчас. Так точно, да?
Professor Kirill. Professor
Yes,
Kirill,
exactly.
Professor Kirill.
В обратную сторону. Yes, I'm listening. One second.
We have
Is it okay now? Yes, Professor Raju wants to say a few words.
Sir, so Professor Kirill, I know there is another delegate in the meetings and plenary
She's
session,
open.
Rear Admiral Preetham Lal. So I think we have to request Rear Admiral.
Пожалуйста, наверное, конечно. Yes, sure. We are looking forward to these words.
So now may I request Rear Admiral Preetham Lal, Senior Advisor to SADM and CII.
Да, так точно, пожалуйста.
Yes, please. Of course. Yes, please.
Yes, please.
Rear Admiral, sir.
Yes, please. Can you hear me, please?
Yes, sir. Yes, sir.
Thank you. So to begin with, a very
Listen,
good morning to all my colleagues from the Indian side. A very good morning also to all the participants from the Russian side. It is indeed an honor and a privilege for me to share this space with the highly acclaimed persons who are on this panel for the plenary session of the webinar on nation building through shipbuilding. And at the outset, I would like to thank the Pondicherry University and the SMTU for organizing this very nice webinar and also inviting me to participate in this. So thank you very much to begin with. Already enough has been said about the nature of changes that are taking place in the shipbuilding, be it design, be it construction, be it materials, and all the technological inputs that go into it. What I would like to do is stick to the core points related with the concept, the basic theme of the webinar, which is nation building through shipbuilding. Of course, the educational and institutional inputs have to come in too. So I would like to just highlight a few points. One, shipbuilding industry is considered as an important and strategic industry the world over, both from the economic as well as the national security perspectives. And therefore, this industry gets support from several other sectors of the nation's economy, be it shipping, be it transport, energy, and many sectors of the manufacturing industry, such as steel, light engineering, heavy engineering, electronics, electrical, and IT. The modern techniques have called for even more, digitalization, even more inputs from the IT industries in design of management systems, so-called platform management systems, machinery control systems, automation systems, and so on and so forth. Therefore, it helps the shipbuilding industry as such, helps to develop a lot of local industrial infrastructure as well as infrastructure for national security. That is for the purpose of building naval ships and submarines, providing them life cycle support and providing them the logistics support. So in a way, shipbuilding industry can form one of the major pillars of economic development of any nation. Traditionally, shipbuilding has been a very labor-intensive industry. Therefore, employment was really large. And now, with a lot of technological inputs that have gone, a huge amount of efficiencies have been achieved through employment of these technologies for design, testing, construction, and integration of ships. But let me tell you, it still requires the shipbuilding industry, modern shipbuilding industry as it is today, still requires a lot of employment of highly skilled personnel. Now, equally important to reckon with is the multiplier effect which the shipbuilding industry brings to the overall economy through other sectors. In fact, several global studies have been undertaken, and it has come out that each job that is created in the shipbuilding industry requires at least 7 more jobs to be created in the related industries, be it for steel manufacturing, be it for fabrication, be it for design, simulation, cables, electrical systems, electronic systems, and so on and so forth. And that is why the shipbuilding industry has a very huge impact in any nation that you can see across. You can look at Japan, South Korea, Taiwan, China, and now Vietnam, how their economies have leveraged the shipbuilding industry's infrastructure. Now, given the above, as far as India is concerned, it's a peninsular nation with a huge amount of huge length of the coastline. It has no major land routes for conducting its external trade. In fact, 95% of its trade by volume and 75% by value is conducted through the sea routes. Now, given this, and that all the most important critical resources, that is oil, gas, and things like palm oil, etc., are required to be imported for India, it is very important that we have a very, very vibrant and capable shipbuilding industry. The key otherwise is most of the additional fact that needs to be looked at is that most of the cargo ships that sail from East Asia to America, Europe, and Africa, they all pass through the Indian territorial waters. In fact, in certain cases, there is also lightages that take place in the Indian Ocean areas. That itself also provides a major opportunity to the Indian shipbuilding industry to give support, that is repair and refit support, to several ships that transit through these areas. Now, the key for Indian scenario is that it looks disheartening that the present state of the Indian shipbuilding industry, which is largely dominated by the public shipyards, they have engaged mostly in construction of the warships and submarines for the Indian Navy and the Indian Coast Guard. And this aspect was very clearly highlighted by Jayant Patil also. Major private shipyards, except probably one, who were thriving till around early part of this last decade, are no longer actually in active business. Of course, general global slowdown, both in ship construction as well as economy since 2008, have also contributed to their woes and the present state of affairs. Now, the key here is, from here, when global economies are just about coming out of the pandemic, and otherwise also global economy is looking up, how do we take advantage of the shipbuilding industry, both in Russia and in India, to leverage the industrial infrastructures that we already have and make a major contribution to the overall economies of the two nations? From the India's point of view, we have a merchant fleet of over 1,400 plus vessels, which represent about 12.8 million gross tonnage capacity. But 90% of this fleet is from shipyards outside India, as far as their construction and origins are concerned. Most of the ships in India are more than 15 years old. And probably this is the case in many other global fleets also. That means there is a huge opportunity, because there is a necessity for large-scale renewal of the merchant fleets of the world. Both of us, India and Russia, should consider this as a major opportunity to leverage shipbuilding industry to make major contribution to the economies of the two countries. And I feel that as global economy will rebound, shipbuilding industry will bring in enormous economic opportunities which can be harnessed. It is in this context I see the India-Russia partnership should also consider joint efforts to revitalize the joint shipbuilding industries in the two countries. Probably, we should look at harnessing the complementary strengths that the two nations have in education, in design, technological capabilities, infrastructure, and most importantly, the skilled manpower that is available in India. As the Indian shipbuilding industries, as far as the Indian shipbuilding industries is concerned, there is also a need for the governments to play a role of catalyst and facilitator by way of providing access to financial capital to the industry, subsidies, tax breaks, and policy for indigenous construction of Indian merchant vessels, all types. Probably, in my opinion, similar efforts need to be also taken up with the Russian government in case they have their requirement of the fleets. But the positive side is that the Indian government is now coming around and recognizing shipbuilding as a key area for economic growth. In fact, if you all remember, shipbuilding is already given the status of an infrastructure sector by the Indian government. Earlier, we also had a method of subsidies. But over the last 7-8 years, most of the focus of the Indian government was towards the shipping, not the shipbuilding. That means ports, waterways, Sagarmala, and those kind of programs that were actually taking priority over shipbuilding industry, which took a back seat, right? But there is a good news. The news is that since November 2020, Government of India has created a new Ministry of Ports, Shipping and Waterways. So we do hope that there will be more focus for the long-term strategies to revive this fledgling shipbuilding sector in India and towards harnessing the potential of the industries, the design houses, educational institutions, and infrastructure of both the countries. I do hope that during the remaining sessions of this webinar, the delegates will deliberate on several areas of cooperation between the Indian industry, Indian educational institutions, and our counterparts on the Russian side, and will throw up many proposals to be taken to the government so that we can, in the years to come, take advantage of the boom that is likely to come in shipping after the downward trend that has been in place for almost a decade now. With that, I would like to close my remarks and thank you once again for inviting me to be a part of this plenary session. Thank you.
Большое вам спасибо. Индийские коллеги.
Thank you very much. Indian colleagues, we have finished the session, the welcome session and plenary addresses. Now we turn to session 1, modern shipbuilding. Here, co-chairs of the session are honored President, Hero of Russia, the honored citizen of St. Petersburg and professor of Marine Technical University, Vladimir Alexandrov, and Vice Admiral Deshpande. I give the floor to Vladimir Leonidovich Alexandrov. Good afternoon, dear colleagues. I'm happy to welcome all participants of Russian-Indian webinar, Nation Building through Shipbuilding. I liked a lot the plenary speeches. They help to understand deeper the goals that we set, the Indian nation sets and Russian Federation sets. And as the Professor Turichin in their address said, that shipbuilding is one of key elements of international cooperation, and shipbuilding gives a lot of opportunities for many sciences, for many technical directions. So this meeting is highly required and very effective. I hope that today we will exchange our opinions. For the last years, Russian shipbuilders reached a lot of goals, and it is related to the fact that Russian government understands very clearly the importance of modern industrial politics, and Vladimir Vladimirovich Putin, the president of the Russian Federation, pays a lot of attention to the development of techniques and technology, as well as shipbuilding. Our government visits regularly design bureaus and our shipbuilding yards, and we develop a lot of programs, not in terms of Navy shipbuilding. It is one of key elements of the Russian and Indian collaboration, but also transport shipbuilding, fishery shipbuilding, and as you know,
Hello.
unfortunately, the connection is lost again, so I cannot hear the Russian side.
I think, okay. So, madam, you are not using the same net connection?
Me?
Yeah.
Can we start our session, please? This is Admiral Deshpande speaking.
Hello. May I now request Vice Admiral Deshpande? Because there is some problem from their side, so better we can start.
Okay.
Professor Raju, I think that we should give to Professor Alexandrov to end his presentation and talk, and after that we'll pass over to Vice Admiral.
Okay, go ahead. If you have come back, go ahead.
Можно. Так сначала? Да, да. Ну, как посчитаешь. Сейчас тебе. Так что, можно говорить? Да, можно.
So we continue the presentation, dear colleagues. I'm happy to welcome the participants of our Russian-Indian webinar, Nation Building Through Shipbuilding. For me, it's really important to understand the condition of shipbuilding in India. I'm connected with it starting from 1967, and we will share all the developments that Russian Federation has. I'm happy that the government of Russian Federation and the President Vladimir Vladimirovich Putin pays a lot of attention to organize modern shipbuilding as a key direction in terms of reinforcement of defense of our country, as well as providing the conditions for economic development of our country. We search for new ways of development in shipbuilding, and for us it's really important to understand what we need to do in the near future to answer the key questions. First of all, this is the increasing of quality in shipbuilding, the technical indicators, the terms of building ships, as well as economic questions, because our consumers, ship owners, this is one of the key questions. Today on this session, from the Russian side, we will listen to two speeches, two presentations. I would like to give the floor to a very famous shipbuilder, Mr. Seredokho. Thank you, Mr. Alexandrov. I would like to give the floor to Vice Admiral Deshpander, co-chair of this session.
Thank you, and it's a pleasure to.
Сейчас поменяем. Правильно. Правильно.
Thank you, and it's an honor to be along with Professor Alexandrov as the co-chair of this session. This session, I presume, will concentrate primarily on technologies. I can see from the title of the papers, though I couldn't see the papers themselves, but from the title, one can see that there are different aspects which are being covered in innovative technologies. So, one speaker will speak about the materials, composites particularly, which is a very interesting material to deal with. Another speaker will tell us about the build strategies. Yet another speaker from the Russian side will talk about dimensional control and so on. So we have totally 4 speakers, and I'm particularly looking forward to hearing them all. So I will not stand between you and the speakers. So I would now like to invite the first speaker to present his paper.
Так, первый доклад поставлен от имени директора Средненевского судостроительного завода.
First report from director of Srednyenevsky shipyard, Mr. Sereduch, and it will be presented by Mikhail Alexeyev. Good morning, colleagues. Can you hear me? Yes, we can hear you. I would like to share my screen.
Видно ли всем презентацию?
Can you see my presentation now?
Видно презентацию?
Yes, yes,
Can you see?
yes.
Yes. Yes, please go ahead.
Тогда начну.
Then I will start. I would like to say that the yard that we are working on, Srednyenevsky shipyard, was founded in 1912, and more than 500 vessels and ships were built within its existence. Currently, we are specializing on construction of ships made of composite materials. We use modern materials and technologies that I would like to describe. I will start with the materials. Main reinforcement materials that are used: carbon and glass fibers, different density, from 200 to 1,000 grams per square meter, and closed poured PVC plastic material that can be laid in the complex and create the complex shape product. It allows us to produce the structures with the high fire-resistant facilities characteristics. Here you can see the monolithic structures produced by our company: plastic and glass fiber, carbon fiber, as well as composite valves and fittings and fixtures that we are producing within a few years, and we've managed to produce the fixing materials made fully of composite materials. It's much lighter, cheaper, corrosion resistant, and we are planning to use these composite fixtures, hardware, it will be available in the market. Anybody can buy it in the retail shop, both for domestic purposes and for the construction industrial purposes. Here you can see 3 layers structure. Main advantage of this material comparing to 1 layer, increased strength characteristics, and light weight. Inside the filler, you can lay the electric cables. PVC plastic materials can also be used. Talking about the projects, here is the largest ship in Russian Federation being built of composite materials, length about 100 meters, and the entire casing is made of composite materials. We exclude the crackings. Monolithic hull structure is built, the largest hull structure in Russian Federation. It was developed by our company. We are working for a few years on this project. We cooperate with foreign companies. Vacuum infusion is one of the technologies used. The ship presented on this slide is fully made of composite material. It's a military purpose ship. That's why reduction of fields, physical fields, is truly important. This is the main reason for choosing composite material as a hull structure material. Here you can see passenger vessel, which is made of carbon materials. Vacuum infusion is the method used here as well. This is how we reduced the weight, increased the propulsion systems. 150 persons is the capacity, passengers capacity. It's a marine type vessel. And since it's a marine type vessel, Russian Maritime Register is setting very strict criteria and demands to this class of material. This is the first time when this type of class of the vessel was built of composite materials. We have performed testings, and the vessel was certified in compliance with the demands of Russian register. And currently, it's located in the south of Russian Federation in Sochi, performing the transportation of tourists. We have already concluded a few contracts for supply of such ships. It's quite popular in the touristic sphere. Similar type vessel was launched in our dockyard a couple of months ago. Scientific research vessel called Pioneer. Here we have taken the structure of the ship catamaran presented on the previous slide. Technology and materials remained the same. Carbon composite materials were used. Here you can see the boat. We have built about 10 boats of this type. This is our permanent contract, ice class vessel. Due to strong hull structure made of metal, superstructure, bridge made of composite material, the interior is decorated with plastic. High-speed vessel can be used for customs, other similar services for some fast, high-speed operations. Talking about composite materials, we understand that there are many companies dealing with these composite materials. To be competitive in our plant, we set highest requirements and demands to the quality, reliability, and the cost of the products made of composite materials. We think that introduction of modern technologies on all the production stages can help us to achieve the required parameters. I will describe the approaches to design and production used in our company. On this slide, you can see the ability of modeling of reinforcement material installation in the matrix of the product. We can see the way the material is laid in the software on the computer. We can foresee where it's necessary to do the cuttings and the way the material is to be installed when we have a complicated shape of the vessel. We create the charts of cutting, different albums, and we get the data for the machines which are going to process the material further on. Talking about strength calculation or computational analysis, in our work, we split it on 3 stages. First, research calculation and detailed calculation. What's the difference? In the very beginning, when we plan production of the product, we cannot take into consideration all the details of the production that affect strongly the strength and the cost and the reliability of the ship. So first, we just work with the design and with the project. Then we approve the design. And after that, we work with the details of geometry. We calculate the number of layers and describe their performances. And finally, we take into consideration all the cuttings of the materials, the coatings, the pathways. This allows us to avoid the places where the reserve coefficient is much higher than acceptable. This allows us to reduce the cost and prevent wasting the material. A lot of time and resources are spent on production of samples. And talking about vacuum infusion, to work on the infusion schemes, we need to make tons of the samples. So in our company, we introduced the modeling program that allows us to model, to simulate the infusion process, where we model vacuum ports, check everything on computer, and after selection of optimal impregnation scheme, we do the samples. After that only. Here you can see the pictures from the workshop. This is what the operator of the machine can see. These data that were received by designers as a result of their work are transferred into the workshop. And in compliance with this program, the reinforcement material is laid and processed by the operator. We also consider that a large contribution in the cost of the item is set by the equipment. In our production, we try to reduce the human factor to the maximum possible extent. For this purpose, in our company, we use automatic systems for degazation, vacuum insurance, and controlling the consumption. Within the time that we are working, within the period of work with the composite materials, we have faced a lot of different questions. Upon the result of our work, we can say building the environment for interaction between the technologists, designers, and operators in the production is possible. Creation of such environment is truly efficient. It allows to reduce the time of the design and production of the item, allows to increase its strength characteristics, increase the inter-repair intervals, reduce the cost of periodic repair works. Thank you for your attention. Mikhail, thank you so much. Thank you. That was a very interesting report. Very interesting technology of building the ships using composite materials. Now, we would like to give the floor to Goa shipyard. I would like to request our Indian colleagues to introduce the speaker and his report. Application of modern technologies. Goa Dockyard.
Of the next presentation, use of modern techniques in shipbuilding by Goa Shipyard.
Hello everyone. Can you hear me?
We can hear you and see you.
I would like to share my screen. So we are a small shipyard in the west coast of India. I would like to just discuss about the things that we have introduced in our shipyard for improvement in the shipbuilding process by means of cost cutting and time also. As pointed out by Mr. Jayant of L&T, that we have already, Indian shipyards have already gone ahead with introduction of many new technologies over the years. The problem with the smaller shipyard is that we have to compete with the other big shipyard. We have to have a very high quality of technology advancement or a specific project group. For that, I would just like to I would like to introduce what we have introduced in our shipyard. So I would like to discuss the 4 points. One is in the form of how we are trying to manage the big database, the drawings, and payment, all other things through ERP-based softwares. One of the difficulties or difficulties that we have faced, that we are government-owned shipyard. So a set of policy, set of rule regulations that we have to follow compared to other private sector shipyard. We cannot introduce or buy something that we want in maybe in a day, that we would take maybe 2 weeks, 3 weeks, that because we have a very set of rules, regulations to proceed with the procurement and everything. So these 4 points that I would like to discuss. One is the ERP-based project management. Then that shipyard has introduced FEM analysis software in the beginning of this, in the beginning of 2000. And then we have focused on the FRP and GRP, which in the previous discussion that colleague has shared. And the 4th one is the ship lift facility, that only few shipyard has this facility in India. So we'll go ahead. So this is the layout of our shipyard. This is all modernized now. This is a ship lift facility. This is outfitting jetty, you can see, and this is our GRP complex, which is capable of handling maybe 70 meters of ship. These are our outfitting workshop. This is our steel assembly workshop, ship workshop, and these are our technical offices. So we have undertaken digitalization since very beginning. I would like to share my next slide before. Goa was under Portuguese rule before 1961, and this shipyard was established by Portuguese in 1957. In 1961, when Goa was liberated and became the part of Indian government, Indian country. So from there, this has become one of the government-owned shipyard. In 1985, we have introduced electronic data processing center for payroll, paying and labor costing, because the government functions in such a way that they want a fair play as well as try to stop any option of corruption. So this is one of the best way to reduce to increase the transparency, I'll say. Then further on in 1988, you can see that we have introduced CAD/CAM, then computer-based 3D design and structural modeling, steel cutting information. These all things are which is a very essential in every shipyard. This we have introduced. I'll just next slide. Then further in 1990s, this Autocon software we have used, and the Tribon, which was the earlier version of Aviva that we are using right now. Then further we have integrated the design with our ERP-based system. So any department, whether it is design or not, they can access the design, and they will do this necessary work for themselves. Then we have Aviva Marine software for designing the ship. We have ANSYS for CFD analysis. Structural analysis, we have FEM software like Nextran and Patran and Alice Dyna. Then we have BAN for other items like bill of materials, production inputs, and everything. So these are the points that shipyard has undertaken over the years to enhance the productivity. Now, this is the ERP capabilities. This has been used for project monitoring, online vendor registration system, bill tracking system, and e-procurement portal and e-banking. The main purpose of ERP introduction is to increase transparency. As I said, that since it is a government-owned shipyard, we have a set of rules and regulations that we have to follow. With the ERP, we have greatly enhanced the processing timing. Things which used to take a month now can be done in 1 or 2 days. So next. This is how the system works. You have a project database management software. We have a design center. Now we have a planning department, and these all are connected to ERP. Recently, we have introduced a data management software. So what actually happens that we have a whole lot of drawings that we have secured on a database, and this is something new. Actually, many shipyards has already introduced, but this is something new and advanced in a way that now we are any design or anything can be accessed through a main centralized server. If a design which has been made in 1980s can also be accessed by anyone without any difficulties. So this is something new that we have introduced this year. We have a digital library, user control, so that modification and rectification of data can be controlled. As I said before, that we have a pattern and Einstein FEM software for finite annual analysis, and then Alice Dyna for non-linear static or dynamic structure problem. We have ANSYS for mainly that we are using for resistance calculation. These all things has been introduced in the past 5, 6, 7 years. Before that, we used to outsource these things. This is the modeling which we are using Aviva Money software. These are the 3 lines are there, and then one is outfitting module. This is FEM, finite element analysis. This is the image of a stress plot. This CFD analysis, and this is shock and vibration analysis, which we have undertaken for one of our recent medicine. It's a government plan to modernize all the shipyards in this country. We have undertaken this thing, and we have introduced this one shipyard facility, which is very rare in India, and 4 sub-assembly block. This is construction way, outfitting jetty. So this is something new and that we have introduced. This is FRP GRP basic construction capability. One of the fast interceptor boats that we have delivered to Mauritius. This is the process that we are following. In the previous discussion, they have shared this thing. They have shown the material and everything. The same thing we are using, but we have a different place, a different kind of working model. No. These few of the ships that we have manufactured in GRP facility. Inside of FRP boat. Inside of FRP boat. This shipyard facility is the first to be installed in a defense public sector shipyard in India. And this facility is 6,000 ton capacity, 120 meters long and 20 meters wide. Lifting capacity is 6,000 tons. You can see in the 3 images that how these things are being used. The problem with the smaller shipyard is that we have to have some product which no other shipyard or no other company is making. Then only that is the only way of we can be competitive. So this all modernization and everything is aimed to do that. Like introduction of FRP or GRP facility, these facilities we are processing ahead in this direction. This is our diversified project. This damage control simulator we have done for Myanmar. This FIB, fast interceptor boat, we have given to several countries. This is simulation center for oil and gas that harbor model that we have given to one of the client who is working in the offshore field. This we have given to our local airport, local defense airport, so that they are using it for training and all. Okay, so this is all from my side. Thank you.
Спасибо за очень интересный доклад.
Thank you very much for your interesting presentation. Now we give the floor to Admiralty Shipyard, and this is the presentation by Mr. Rogozin, the chief technologist. But the report will be given by a young specialist, postgraduate student of the university, Kirill Budnikov. So the topic of the presentation is dimensional control technology information of hull structures. Good afternoon, dear colleagues. Mr. Rogozin will give the entrance word.
Знаю, что там хорошие судостроители, хорошие моряки.
I know there are good sailors, good shipbuilders, and our report is dedicated to one of the main elements of the ship, and the task here, the hull structure, is about 40% of shipbuilding scope of work to minimize the construction cost That was one of the tasks, maintaining the quality, and dimensional control is the methodology which allows us to achieve this. Interaction between designer, technologists, and production workers allows to do this. The report will be presented by representative of Marine University, Kirill Budnikov. Thank you, Kirill.
Hello.
Unfortunately, there is no sound. The translation cannot be rendered.
We can hear you.
Yes, but there is no sound. Video goes without sound.
Прошу прощения, у вас звук не слышен. Вас не слышно. Санкт-Петербург. Сейчас слышно.
Составляющие задачи соглашения резолюции третьих государств, соглашение точности, подготовления,
The translation is not possible. Interpreting is not possible because there is no proper sound. The speaker is not audible.
Прошу прощения, Санкт-Петербург, вас не слышно, шум слышно, а доклада вообще не слышно.
No sound, so interpretation is not possible.
Я помню ваш любимый вопрос.
Сказать. Переводчик слышит? Это Швей байки рассказывал, когда долбал. Дима, с переводчиками все время держите контакт полный. Долбает, ну, начинаешь рассказывать. Ну, слышно, Дима, или нет? Переводчики слышат?
Переводчик нас слышит?
Да, слышно.
Отлично. Ну что ж, наконец начинаем.
Вы можете покороче, Кирилл.
Хорошо.
Погромче. И погромче,
Хорошо,
да. И останавливайте. Привет.
Одно из важных...
Это Глеб. Привет. Глеб Андреевич, привет, дорогой.
Здравствуйте.
Садись прямо туда, может, сейчас там свободное место.
Одна из важных составляющих задачи
One of the important tasks of increase of production of shipbuilding is the improvement of accuracy of ship's hull structure building. The hull structures cover about 40% of cost of total amount scope of work on shipbuilding. So the accurate size, accurate dimension, pure dimension is important. What is pure dimension? Is the method that allows matching of the items of components at the slipway stage. So that means that generation of assembly units is done with the minimum tolerance that cannot be cut out from after assembling. Currently, the task of supporting of keep sticking to the geometrical dimensions, this task is solved by the compensation method. In this case, the design work is limited to the development of the scheme of hull structure division on sections, but the number of control lines is defined in compliance with standards, work and design documentation, when designing separate structures. The principle of basis unity is not taken into consideration, and the dimensions are set by an order. The technology of dimensional control is based on the principle of interchangeability. The process will be more efficient from economic point of view if the components will be adjusted without matching. This technology allows to produce the structures with the maximum accuracy. The methods of measurement of geometrical parameters of structure applied currently do not ensure the required accuracy. To build the ships in compliance with pure dimension technology, we need to perform a number of activities, design activities that involve the elaboration of hull structure designing, technological processes, and production processes. Technological processes cover the unity of measurements, justification of all the solutions, and forecasting of deformations. Production include the strict control of technological discipline, assurance of accurate assembly welding parameters, creation of unified dimensional measurements database includes the unity of measurements. All the measurements during the ship structures production are to be done using relevant measuring tools and in compliance with the unified measurement methodology. Each section has a deviation from nominal dimension. We face the problem of defining of optimal section location, as it is shown on the slide. Optimal position can result in the complex deviation, and this deviation are not known to us currently. How to solve the problem, the issue? We can describe it with a simple example. If you cut out two pieces in a random shape, then there will be a eternal number of matching of these pieces. But if you cut it in a different way, then there will be less number of probable matchings of such parts. The hull structure will be crossed with the control lines that deviate from the basic planes of the vessel.
While adjusting the components, the control of sections and blocks should be tied together, or between them there should be some size. And if you do not follow this rule, it will lead to not compliance to some elements and wrong tolerance. The control lines should be included into the work drafts and should be the base for work chains and measuring and marking the draft. So different layouts are marked differently. So the control line will set the edge where the marking is being done. You can see it on the picture on the right. And you can work out control lines. You can also work out the tolerances to produce block sections that ensure their compliance on the slipway. So unfortunately, in our realities, this rule is not followed all the time. And if we look at standards, the section will be measured from the edge to the edge of the section. And on the slide, on the left, you can see all three measurements. They are equal, they are uniform, but none of them will characterize the actual length. The actual length will be L4 size, because all the parts of the section will be deleted while adjusting to make sure that there are tolerances. And if we look at the control line and check all elements, all 6 sizes to ensure the minimal tolerance should not be more than 3 millimeters from theoretical indicators. On each unit, there should be not more than 3 control lines. So you can see these lines parallel to the main. And to ensure the comfortability of work, you need to have more control lines. And you can see in the slide control lines over the bottom section. Today in Admiralty shipyards, we have it ready, and the requirements to design and ensuring the technology of the size control we do not have. In order to come up with the right size, we need to work out the requirements to design. And these are we need to ensure that we have documentation which is fully detailed, and we also need to add the following information. The assembly of the hull, and we also need to put all the assembly units into the mounting zones and to check that the system of control lines is implemented. We also need to make sure that we've designed specific tolerances according to the analysis, according to the length of hulls of ships. And this will increase the costs, but due to the reduce in volume of works, it will much more bring, and we will have it, we will save much more money just by reducing the volume of works. We also need to take into account the correlation with these control lines, and all design decisions should take into account scientific basement and forecasting regarding the deformation. We need to regularly optimize the methods, how we calculate the deformations, and also welding equipment. welding deformations are just a normal consequence of shortening the details, and we cannot avoid this. However, deformations should be minimized due to the use of welding stitches. We will reduce the number of welding stitches, and while designing the hull and while processing the hull, we do not analyze possible options of assembly from welding point of view. So we just mark these welding tolerances intuitively. So we need to check, double check this construction in terms of welding deformations. We also need to provide the precise indicators that will ensure safety regulations. Following safety regulations, we will avoid human effect, and it will be very helpful. Thank you very much for your attention. Thank you, Kirill. Please give me, I will give the floor to the representatives of our Indian colleagues. So we give the floor to Mr. Hrishikesh Narsimhan, General Manager of the production.
Yes, thank you, Madam. Can you hear me?
Yes, sir.
Yes, we can.
Okay, and just give me a minute so that I can. I can only share the screen when the other participant takes away. So I think the screen is being shared now, so I cannot start. Hello. Hello, am I audible now?
Yeah, yes.
Okay. I would like to share the screen now, so I'm just going to share it.
Yeah.
Is the screen available now?
So are you trying to access to the screen?
Yeah.
Yes, I'm trying to access the screen. Can you see the screen?
Yes, sir.
Yeah,
Yes,
it's
sir.
okay.
Okay. Good afternoon to everybody, and especially Vice Admiral Deshpande and our honorable guest, Mr. Vladimir Alexandrov, and all the Russian and Indian delegation and my guest speakers. Thank you very much, sir. Good afternoon. Can you hear me? Am I audible?
Yes, sir.
Okay.
Yes, sir.
So my name is Hrishikesh Narsimhan. I'm the General Manager and Head of Production of L&T Shipyard. And I'm here to talk about modern shipbuilding, sustainable and efficient naval shipyards. So I have to first thank Dr. Vladimir Rogozin, who very nicely spoke about hull dimensional control. So I am also going to speak a little bit about it, and his introduction is very nice because it also shows how complex hull control is in a shipyard. Thank you. So before I get to the main topic, I have one small introduction. That is, you can see in front the Indian shipyards which are there today, and the ones in blue are shipyards that are building. Most of the shipyards in blue that you can see are owned by public sector, that is the government, and only L&T is the only large private shipyard. And most of the yards which are in blue are making naval ships. The ones which are in green are also doing well, and they have managed to survive the 10 years of recession, and I think they are in a position to go up. India, as you know, the Indian government has been promoting shipbuilding for quite a while, so that shipbuilding can also contribute a lot in nation building, and they wanted shipbuilding to keep abreast with the growth of the Indian economy, because many other sectors have done exceedingly well. And few of the points that the Indian government wanted was make in India, get self-reliant, and we can see that especially in the naval shipbuilding sector, one of the key agendas of India's policy was indigenization, and we can see that for naval ships, for the float and move activity, we are positively moving in the right direction for indigenization. So this is one success story. But just like India wants its military force to grow up, India also wants to have economic strength. And this is one area where Indian shipbuilding has not caught up with the rest of the growth of the Indian economy. Now, the Indian government has been following the lessons from the East, and just like Japan, Korea, and China now have followed a method to grow their economies in shipbuilding, the Indians also followed what the Koreans did. The Koreans gave government guarantees. They handed over ships to revolutionary companies like Hyundai, Samsung, and Daewoo, and created a strong competition for export. You can see that the Indian government also has been very supportive of Indian shipyards, especially in the financial areas and giving guarantees. They have followed it up for the last 15 years. They have also encouraged privatization in shipyards, private companies to come in and take over many government contracts, and created a strong competition between public and private. Also worked on public-private partnerships. Universities for shipbuilding and encouraging technical training has also come about in a big way. But the one area where we could not really break through is developing a strong in-house production technology, which is what is lacking. And I'm talking about the basic issues that can productivity improvement be possible in naval construction? How can efficient assembly lines be a strategic competency for India? And I want to examine what kind of a model will work for Indian yards to compete with the Southeast Asian yards. Now, I must tell you that when I was researching for this paper, I found out that before I come to that, this part about productivity improvement has been highlighted also by the Indian government. And you can see in the Maritime India Vision paper which has come out, they have found out that when it comes to being competitive in international markets, the material costs in Indian shipyards is about 13% more than the Chinese. As far as financing is concerned, the rate of interest that we give to Indian companies is about 26% more than China, which is of course the lowest. But when it comes to labor cost, even though India is a low-cost country, we are still 52% more than China, and about 50% more than Japan and Korea, which have really developed economies. Which means that we have to focus on productivity, which is the one area where we really need to move our yards up. I also started to check out if there were other reports on productivity, and I found a similar report made by Mr. Shi Lian Chao and Yi Hyun Ye, which is just came out in 2020, comparing all the major yards. And we found out that yes, true enough, the Japanese yards are very productive, the Korean yards are very productive, and the Chinese yards are getting there. But I found out that when it comes to the sustainability of the yard, productivity is not the only issue. And this I found out because one of the yards of Korea, which has got a very high ranking, SSP Shipbuilding, I had visited the yard in 2004. And while writing this article, I called up my Korean friend and I asked him, what is the status of the SSP Shipbuilding? And he said, well, SSP Shipbuilding has currently gone bankrupt after this report has been written. So I would like to say that, yes, productivity is a major point, but shipyards need also be profitable to sustain. And the British, and now I am talking about yards, when they lose competition, their first issue is how to be profitable. So the British yards, after 1980, started to become, I would say, less and less competitive in international market. And slowly, for the British yards to survive, they started to take more and more naval orders. So Britain, which was at one point of time one of the pioneers in shipbuilding, today has only military and government orders in their shipyards. Now, as you can say, British yards have about 93% orders from the Ministry of Defense. So in 2005, the British government called up rank organization, and you can see that and asked them to investigate how Britain could go back into commercial market. And in case of an emergency, what would happen if, for example, the market required British yards to build commercial ships? Or, for example, what would happen if the British Ministry of Defense for a long period of time do not place orders on Indian yards? In such a case, would the shipbuilding collapse? Can they take up alternate orders? So let us see what happened with the report. Firstly, they found out that most of European shipbuilding is concentrated on naval ships, as defense orders are more attractive than commercial orders. Certainly, in my company also, they say if there is a choice between defense orders and commercial orders, naval ships offer a higher profit. The military contracts have a lot more engineering and are more complex. It allows higher value engineering to be indigenized, which also means that a company like L&T can also backward integrate and make other engineered components for naval ships. It allows us to put money into the yard for large infrastructure developments. And finally, we have less competition from overseas yards. I mean, if you hear the name China, most of us get nervous because Chinese can get any contract they want. And we can see that warships, which are built even by European countries, are mostly for domestic use with limited export. But naval yards have a few disadvantages. First is that lean periods and long lead items between contracts exist. And to even out workload, sometimes commercial fillers may be required. Also, we found out, at least the report says, that to get the competitive edge, to keep the production speed alive all the time, the motivation is required. Actually, to be frank with you, when I was told that I need to write this, I was supposed to write, make a presentation, but usually when you have the fear that, oh, my presentation is coming and I have not written something, then the competitive edge in you goes and you work much harder. So competition is required to speed up production. So what would happen now if, and finally, shipyards are opportunists. We feel that because of the new environmental laws, maybe another shipbuilding boom could be triggered off within 3 or 4 years. So in shipyards are opportunists. Can one sit through a boom time in commercial shipbuilding without dipping one's hand into the pot of gold? What I mean to say is, like when the stock market is going through the roof, can you be investing in bonds? So let us see that. So let us understand if the construction of naval ships are much different from commercial ships. When the British took a poll in all the Europe and found out from the shipbuilding people whether they thought that naval ships are much different from commercial ships, well, I would say that the survey was 50-50. Some people said yes and some people said no. I've been in the shipbuilding business for a long time. Yes, there are certain differences, but sometimes if money is involved, different shipbuilding people have no problem getting into commercial shipbuilding, and it's relatively easy. So, but there are of course, some differences, and the major difference is naval shipbuilding consumes man-hours. Commercial ships consumes manpower. I can discuss this at length, but maybe I should move on, and because there are mostly shipbuilders here and they understand what I mean. Naval hulls are more difficult to build, and they are more stringent classification and inspection rules. But and the time taken is high, but I would say that the manpower required is not as high as when you are building commercial ships. So let me go back to my scope of presentation. Is the search for productivity possible in naval construction? Yes, and we have to do it. The second part is, how can efficient lines be put in Indian shipyards? Now, we must understand, a lot of people tell me, so why do you find process improvement so hard in shipyards? Let me tell you that Dr. Vladimir was explaining exactly how to do improvement in the hull structure. It required a doctor to understand what was going on. So in short, when you have an assembly line in a car manufacturing factory, you can change the process at a particular stage or change the method of manufacturing, retrain the technician, give him a new skill, and you can make a change in the production improvement in a car assembly line. But in shipbuilding, it is difficult because shipbuilding is in between project and processes. And any change in process in shipbuilding requires multiple stakeholders to agree. And it's a new way of doing work. It calls for a cultural change, not just a structural change. So, for example, the production technology in block making requires you to first define the welding sequence, minimize the locking points, try to minimize the distortion due to heat, keep the weld size low so that the heat input is reduced. And you have to do a lot of planning to make sure when you change the process that the welder, the fitter, the grinder is kept occupied, because when you change processes, many of them become idle, and this has to go on. And imagine now you have to put this, when a new ship series comes, you have to do this for maybe 19 or 20 blocks that are going simultaneously in your yard. So optimizing a block assembly requires you to meet the designer, to meet the production engineer, to meet the go to the bending shop for bending accuracy, the sub-assembly sequence, block assembly sequence, and then finally training the welders for the WPS, that is welding procedure sequences in the welding department, go back to production, talk to the contractors. And then when you have to validate this, it takes almost 6 months, because each block takes around 35 to 45 days to complete. You validate it, you improve it, it takes 6 months to make this improvement. You can see that in the last 2 years at my shipyard, we built 5 aluminum boats, and then we are building a new series of another ship. Naval ships don't come in large series, 5 or 4 or 3, maximum 3, maximum 5 or 6, and minimum is a 2 which means that by the time you put the new process in place, it's time for you to move to the next ship. This is just what we do now. Every block we have a new series, and we are making this for every block. And then you have to fit the pipes in. In short, this is also required much thinking and much planning. So you can see now that when we had this series of ships for the offshore petrol vessel, it took us 4 ships of a series to reach this point of panel stage outfitting, and it's usually very rare to have naval orders crossing 3 ships in a series. So productivity eludes Indian yards because productivity is a function of intelligent labor. You know, the Chinese had to struggle. The Brazilians could never learn from the Japanese. I used to talk to my friends. The Koreans, when they were working in Iran to build an Iranian ship, the Iranians, finally, the Koreans gave up with the Iranians and had to send the Korean full workforce to put production technology in place. I used to joke with the Iranian friends, because Iran and India have very close relationship, that the Indians cannot put production technology in our shipyard because we are intelligent, and the Iranians cannot do it because you are more intelligent. So the point to say is the productivity improvement in shipyard is a cultural movement and not just a mere change in procedure. So now let me examine, if naval yards have to improve, and if we have to compete, and if we have to take the advantage of the low cost of India, the growth of India, and to keep our commercial fleet and our naval fleet both moving up, maybe we have to have some kind of a hybrid model. Now, hybrid models in yards can be complementary, because you can see military ships have customized design, commercial ships are volume business. Military ships are complex, its contract is complex, but it is stable. Commercial ships have simple contracts, but often one very unstable. If the market drops, the commercial person always wants to cancel the order. Similarly, you have elasticity in schedules, which is tolerated when you're building naval ships, because by nature of the naval design, which is concurrent engineering, you have to tolerate elasticity in schedule. But in commercial ships, the delivery date is very rigid. So you can see that both naval ships and military ships complement each other. So, but the key point in putting a new system in place is the managers in the yard must quickly be able to demonstrate to the workforce that high productivity can be achieved when they change the methodology. When you start to discuss on how to plan the block, how to make the sub-assemblies in a certain way, how to give tolerances, many times the foreman at the bottom, he don't agree with the engineers. And sometimes we have to take out very quick demonstration that yes, we can improve when we change the way to do the job. So my recommendation is that naval yards, when they are in a good position, can take some commercial load, and then they should strongly put simple commercial orders in place and show and demonstrate to their workers that higher productivity can be achieved by the thinking and the new way of working. Internationally, we can see also that many shipyards have successfully put the hybrid in place, especially the Japanese. Japanese are masters in it. Kawasaki, IHI, Mitsui, they've all very systematically gone and taken commercial ships of similar size along with naval ships. But you know, the Japanese are very disciplined, and so they have actually gone ahead and planned this out very well and very successful in it. The Koreans, Samsung and HHI, Hyundai, have made in the same yard, but their divisions are kept separate, possibly because the commercial ships they make are of very different size and their steel thicknesses are very high, so the same infrastructure cannot be used. The Europeans especially the Polish, the Germans, the French, and the Spanish, and of course the Russians, they have a different approach as the workforce is completely different. In India, our workforce is not as educated as the Europeans. So Europe certainly has an advantage when it comes to hybrid models. So the two major issues that elude Indian yards is sustainable profits and international productivity. So we are now working on this area. And to conclude, I think that Indian yards, especially those that have survived the last decade of recession, are now full with orders. We're full with orders. We have got work with us. And when you have orders, this is the right time to focus on productivity. Productivity requires repeat shifts, and it requires a documented work process. I always say civilizations that have a written script are able to go and grow in their stature. Civilizations that don't have a written script cannot grow. And modern shipyards cannot ignore productivity, because productivity is a core strategy for any yard's sustainability. Thank you very much, sir. I conclude.
Большое спасибо за очень интересный доклад и интересный сравнительный анализ.
Thank you so much for this interesting report and very interesting analysis of operation of different dockyards. Now I would like to give a floor to our co-chairman of this session, Professor Alexander for his comments, and after that I will give the floor to the Admiral. Dear colleagues, I'm highly satisfied with the report's content that we have heard since I've been working in the Admiralty dockyard within 44 years. I was breathing with this dockyard air when listening to you. Talking about the Srednyenevsky dockyard, I would like to wish them a success. It's a modern shipbuilding company which looks good and competitive in the market, and since today we need to build not only a single time orders, but tens of the vessels are to be constructed. Of course, the management of the plant need to think about the development since they are a part of United Shipbuilding Corporation. And for corporation, it's going to be one of the main directions for the development of the production processes. And we've been talking a lot about the hull structures and the report.
We showed on the example what we need to do. Admiralty shipyards, they increase their opportunities while building submarines, so they really look great. On the Russian market and also on the international market, European market, and we would like to wish them success. And regarding the building of transport ships, as the professor of the Department of Shipbuilding shows, he tells that we should to give workload to people, and we can do so when we have good balance of commercial and transport ships and also submarines and navy fleet. And today Indian colleagues discussed this. I visited Goa shipyard in the 90s, and I remember the shipyard, and I remember how it looked like, and I see the major changes that took place. I think this is a great place, and when we talk about shipbuilders in St. Petersburg, because we have climate situation, so 15% reduction of economy happens because of that. And of course, in Goa there are more opportunities in terms of organization of tests. We of course need to tell that Navy and sea tests contribute a great part, and it really needs long time. And of course, I think there was a brilliant presentation, which was the last one. The materials you discussed were very important, and we need to think and maybe to have a separate seminar in terms of economics, in terms of specialization, and of also the experience. Here in Russia, we lack such materials as the colleague presented here. So I would like to thank everyone for great presentations, for your initiatives, for your warm attitude to shipbuilding, and I would like to wish you success. Dear colleagues, I would like to give the floor to co-chair of this session, Vice Admiral Deshpande. If you would like to give any comments.
Yeah, okay. This is Vice Admiral Deshpande. Very interesting session, 4 different speakers, each one looked at shipbuilding from a different viewpoint. The first speaker spoke about using of composites, and I've seen composite ships, not very large, but the minesweepers variety where you don't want to use steel or you use some special steels, they crack up. And the problem with the composites, which I have faced in the past, is that there are 2 problems. One is that there is a lot of delamination that takes place, and when delamination takes place in a ship's hull, you will end up in serious trouble. Hopefully, the new technologies are taking care of this problem of delamination. Maybe they are using prepregs. When you use prepregs, again, curing them becomes a problem. Storing the raw material becomes a problem. So these are some of the issues with the use of the composites. The second problem with the composites is that when the ship comes in for a long refit for a medium, what the Russians call the medium repairs or the capitalny remont, you take out a lot of this composite material and you don't know what to do with it. You cannot get rid of it. And it's a large volume waste material which you don't know what to do with. So these are the 2 issues I thought I would like to highlight as far as the materials, the composites are concerned. Another very interesting material which I heard about very long ago, they made only one submarine out of that very exotic material, a submarine that could go to phenomenal depths and survive. That is, but I'm sure that it is still under wraps. They made only one submarine and they wouldn't, and it didn't go into serial production. But there are a lot of possibilities when you go into materials, and as my co-chair said, for materials itself, you can spend a whole day talking only about materials of construction. We had an interesting presentation on the from Goa shipyard, a shipyard that I have a lot of regards for. They have always been, although small, they have always been very progressive in their outlook in adapting new technologies. And of course, the dimensional control was also a very interesting presentation. I'm from both backgrounds, aviation and shipbuilding, and I've seen the kind of tolerances that you need to maintain when you manufacture an aircraft. And now slowly, the ship is not achieving that, but they're moving towards that goal of having something machined to a place where you can just quickly weld it. So that was a very interesting presentation too. And I found Mr. Narasimhan's presentation from L&T very, very informative, very well-researched paper, which gave a lot of interesting ways of looking at the productivity problem. And his conclusion was absolutely, you cannot contest. Yes, if you want to be in this business, you have to improve your productivity. You can be a public sector shipyard, you can be a private sector shipyard, you can be a large shipbuilder, like someone who makes Panamax carriers, or you might be a small boat builder. But unless your productivity improves, you will become deactivated, as inactive. You will be soon inactive. Very interestingly, Mr. Jayant Patil in the morning also mentioned the fact, 2 items which I used to sort of talk about quite a bit, and I was hoping that this would catch on. One was modular shipbuilding. We have to go towards that. Whether it's a big ship or a small ship, it doesn't matter, but modular shipbuilding will get you a better productivity than anything else. And advanced outfitting. The ratio of doing outfitting in a workshop to doing it in a floating ship, the ratio is something like 1:7. You will get 7 times more productivity if you do it in your workshop. Do 85%. Mr. Patil claimed 85%. I'm happy to hear that figure, because 85% outfitting done means very little outfitting left for a float condition. So these are all very interesting areas of discussion, very interesting things to follow upon, and we with our Russian friends can interact and exchange these experiences so that both of us can profit. Thank you very much, all 4 participants who gave their presentations. Excellent presentations, and I would like to give them a clap.
Уважаемый адмирал, большое спасибо.
Dear Admiral, thank you very much for your interesting comments. We are almost at the end of the session 1, and we are moving without any breaks, as we agreed with colleagues from India. So now we move to the session 2, modern shipbuilding, and here the co-chairs are the Commander Hemant Country and Valery Kireev from the Center of Shipbuilding Technology and Repair. I will share the screen.
Так, ну, наверное, пока буду передавать. Спасибо, Володя. Так, я предоставляю слово
I give
сейчас
the floor to the Central Design Bureau Iceberg, and the first presentation by Gleb Makiev, who is the chief designer of projects. The presentation is floating power blocks on with a nuclear power plant. Very interesting.
Вот это, да? Это ПБ.
Да, любой.
Любой из них, да? Любой. А ты будешь по ПБ? Вообще по какому-то из ПБ? Вот здесь, да? Так, и пошли вперед. Я могу еще щелкать. Что такое? Окей. Садись сюда. И давай так.
Проявится сейчас?
А что-то выскочило?
Нет, презентация.
А, подождите, а что мы шея не сделали, да? Сейчас посмотрим. Так. Это стоп, опять сейчас начинаются проблемы какие-то. У меня здесь есть. Вот так, шея скрин, да? И вот сюда идем, да? Глеб, это ваш? Ага. Так, ну вот он пошел. Сначала вернем. Так, то есть надо запустить. Ну да, сейчас будет на весь экран. Сейчас, секундочку. Вот он так, да, идет у нас сюда. И, так, а подожди-ка, у нас же шея была уже. Это я не понимаю, почему он не идет дальше. Уже скриншеринг есть. А где сам экран-то? Я мышку не вижу.
Вы находитесь в презентации.
Вроде в презентации находимся, нет? Мы шея нажали на кнопку. Посмотри.
So meanwhile, the colleagues are adjusting the presentation before they start to give the presentation.
Вот она, наверное, сюда, да? И пошли. Все, вперед, ага. Так, прошу. Так, сейчас его щелкается, садись сюда. Хорошо, так удобнее будет. Почему?
Добрый день, друзья. Сегодняшний
Good
доклад
afternoon, dear colleagues. Today's presentation will be about floating power blocks with nuclear power plants. The first such block was designed and built just not recently. It was given a name Academic Lomonosov, the project number 2870. Since 2019, it is being operated. This ship has a long story of construction, but it is more related to organizational and financial issues than technical. So it was designed at the end of the 90s in the 20th century. Then it was adjusted and modernized. So in 2007, the building started. In 2010, this floating power block was loaded and launched, and it was built consequently. So in 2019, it was given to the customer and was moved to the place of its operation. So I will tell you a little bit in details about this ship, Academic Lomonosov, and our new projects that are done by our Central Design Bureau. So this ship, Academic Lomonosov, is not just the ship that goes by itself. Its main goal is to provide energy, to generate energy, but also it gives thermal energy to heat some settlements, because you know in this port city in the Northern Sea route where it is operated, they have problems with heating. So you have two power plants in the ship. They were worked out, and this is the continuation of power plants that were set on all nuclear icebreakers. For today, this power plant has a transshipment interval around 2 to 4 years, and to ensure the possibility of this ship to work within 10 years, we have a transshipment complex on the vessel. Why 10 years? Because for today, we have the rule which says that once in 10 years, we have to provide deck treatment. So once in 10 years, this vessel will go to specific maintenance and repair workshop and will be put in the dock and have repair and maintenance. In terms of complexity and in terms of components, just for us to have the same picture, what is situated where, I will start with the head. Here we have the power plant, and here the energy is given to the seashore. Then we have a machine department, we have steam generators, and we also the steam comes here and is being converted into the energy. Now we have reactor premises. Here we have the doors to nuclear equipment, and then we have transshipment premise. There we take the fuel from reactor and we put the fuel into storage. They go to the back, and then we have additional premises. In any nuclear vessel, we have reserved generators and emergency generators, and they are located there. And in the back, we have a residential block and also the control block. On Academic Lomonosov, just the staff lives, so for their stay, we have created comfortable conditions, fitness hall and swimming pool, also some kind of saunas. From a main characteristics point of view, steam capacity is 240 tons. In new projects, it's even higher. I will tell about it later. Just the period of recharging is about 3 years. So the storage of fuel, they are set for 3 times of accepting fuel. The capacity of turbine equipment is 38 megawatts. Some goes for their own needs and some for energy generating and some for heat generating. If we do not provide heat generator, then electricity capacity will be 70 megawatts. We only can give only heat energy. In this case, the heat capacity will be 110 kilocalories per hour. Now we provide around 30 kilowatts to the city, and we also warm the district, the coastal district of this town. The staff, the crew lives on the board, and it consists of 82 people who can live on the board, and the period of service of the ship is around 40 years, and once in 10 years it should visit maintenance workshop. So this ship is moved by towing or just by dock-wise type of towing. On the upper picture, we can see Academic Lomonosov when it was moved from Murmansk to Pevek in 2019. And as I said, so the ship does not have its own engine for moving because they stay at the docks. And talking about docking, on this slide, we can see Academic Lomonosov in the town Pevek, and we can see how it is connected with the berth, so it can stand tidal movements and also ice influence. It has its own amortizers, and it can stand all kinds of influences of the environment.
Конструкции примерно в диаметре 1,5 метра. И рассчитаны, как я уже сказал,
These are pipe structures that can resist the ice. A very interesting solution is supply of heat energy, since we have floodings and tidings, giving the water under the pressure and with quite a high temperature. We needed very reliable structure that we designed together with our German colleagues, which looks as a set of pipes, tubes, and compensators. If you just fix it next to the mole, it cannot compensate the force at the minimum depth. During the backwater, the fasteners did not resist, so we had to ensure the relevant range. So with the help of this indirect structure, we've managed to achieve the relevant required compensation. So it works. In Pevek, in 2019, first electric energy was supplied, and at 2020 we started heating of the coastal districts. Since there are other requests as well, we have developed the tropical version. 23870 is the number of the project. There are different systems installed. This reactor has an overload interval 10 years, which is matching the docking period, so reloading block could be excluded as a result. But since it's designed for tropical and subtropical conditions, we have decided to exclude the block. There can be a few blocks of this type installed in parallel, And since there is no southern wind, as in Pivek, a wind which speed is 40-50 meters per second. That's why here we are talking about absence of such harsh conditions, so living block is located onshore. So this floating power unit is smaller, but the power capacity is higher. Electric energy produced is going to be cheaper for the consumer. This alternative was developed for tropical weather conditions, and there is another option of floating block developed for southern regions. This is the energy supply vessel that foresees same system rhythm 200M that can produce up to 100 megawatt, but this one is self-propelled vessel. It can come to the base independently and work far from the shore. One of the serious part of the costs when creating small floating dock is the coastal onshore infrastructure, which is quite expensive, depending upon the place of basing, because we need to take into consideration seismic conditions as well. Since we are talking about the regions of tropical and subtropical climate, for many regions, the tsunami are characteristic of the climate. And quite frequently, the onshore structures cannot resist the wave. Here, we can work in a 12-mile onshore zone and resist the tsunami. The waves are not destructive and not dangerous at all. So our mooring system, which is combined with electric energy supply, allows the vessel to rotate above this axis, taking the best position with respect to the wind. This project was developed to supply the energy to a few drilling platforms, and here we also had a task. If there is a natural disaster happening, the drilling platforms stop their activity. We get a chance to sail away to a secure place. This project is also an independent project, though it cannot be used in the northern climatic conditions with big ice fields, just because this system will not resist the ice load. Another project developing the idea of floating power units, academician Lomonosov modernized project 20871. We are developing the technical project for this one. The system is different. Rhythm 200S, interloading interval is 5 years only, but we are going to supply about 106 megawatt to the consumers. We try to build a very similar hull structure, similar to the previous projects, in order to have a replaceability. This project is being built for location which is not far from Pivek to supply the energy to Bainsk mining plant. And this plant, it's more than 300 kilowatt of electric energy. 4 units can be located. One is used to replace the damaged one. Docking period is longer than reloading period. So we take into consideration the fact that one of the blocks is to be replaced. Here, there is no reloading complex. Reloading complex. The decision was taken to replace it with a floating base that will arrive here, or to have 4 of them, and one will be used as a reserve one, as a replacement one. The energy sources are similar to those which are used in PVEC in order to have the compatibility and to have a possibility to replace one with the other one. From the point of view of main characteristics, 305 tons is the steam production. It's higher than on the icebreaker, 22. Here we have the same set of living compartments. Steam turbine system is a new one with a higher power capacity comparing to academician Lomonosov. We use 2, each 58 megawatt. The reloading complex is in fact replaced with one of the turbines in the hull structure because their size has grown. The capacity, power capacity went up, of course, by 30%. Another option of the floating power unit is the project 20872, the same power capacity, but the reactor is a Rhythm 200M. It's a bit bigger and a bit more expensive, of course, but from the point of view of exclusion of this medium reloading in between the docking, the economic efficiency is going to be higher, but it's more expensive, so initial investments are higher. Another option of floating blocks development, project 20873, Rhythm 400 is taken as a basis. It is almost the same as the one which is used on the leader icebreaker currently. Interloading interval 5 years. It's more than on the leader. It's very serious. The power capacity, about 180 megawatt electric energy given to the consumers. Heat energy supply is not foreseen. We are trying to search for optimization and simplification methods. And from this point of view, heat energy is a complicated process. And of course, it depends upon the tasks of the consumers. New floating power units are going to work in Flamsky field, and it's located far from the coastal line. So there is no point to produce the energy and transfer it to such a distance. Only electric energy is transferred. This project also has possible customer and consumer, and it's located far from the shoreline. That's why only electricity is planned to be supplied as well. And approximately 4 or 5 blocks will be required. Today we have a set of versions, alternatives, the way these power units can look like, including the options for tropical countries, desalinization option. The cost of this process was one of the points that they were mainly interested in. In the daytime, the power unit is generating the electricity. And in the nighttime, when the electricity consumption goes down, the energy is used for desalinization. Apart from that, since we all understand that supply of heat energy is more efficient than reprocessing into the electricity, we also took into consideration desalinization with the help of the thermal energy. We have discussed this possibility with Krylov Institute, and we can use this as well. So there is a range of power capacities. Sergey has already arrived. A bit later, he will describe what can be realized. This power capacity can be increased or reduced, and from the point of view of nuclear projects, this is the range. A minimum range for us is not 70 megawatt, because Lomonosov academician does not work currently. There is no energy consumption, so it doesn't work for maximum power capacity. It gives about 30 megawatt. If it does not produce the thermal energy, only 60. There are no consumers currently in that location. Pilibinsk plant is operating. They are working together currently from the point of view of maximum power capacity, 180 megawatt. And the dimensions and the cost of kilowatt per hour will depend upon this. Thank you for your attention. Thank you very much, Gleb Anatolievich. Before I give the floor to Sergey, I would like to introduce our co-chairman. We've missed this. We have two co-chairmen, Commodore Keman Khatri and Valery Nikolaevich Kiriev. I would like to say a few words about Commodore Khatri. From September 2020, he is the managing director and the chairman of board of directors of Hindustan Shipyard. Before that, he worked in Hindustan Shipyard. There is no sound. The interpretation is not possible. Apologize for this delay, for this technical issue.
Должна работать сейчас или перегружаться снова?
Извините, может нас как-то на вас подвинуть меня попозже, то все время попытаюсь, может, кого-то сейчас пропустить.
Нет, смотрите, а я сейчас ведь потрачу время. Я представлю Валерия, представлю Хеманта. Не, лучше, мне кажется, пока они держат в голове вот то, что Глеб рассказал, это же безумно интересные технологии. Да ничего, да, люди подписались, можно всегда пойти на кухню пообедать, там, кофе попить. Это мы не можем выйти, некоторые. Не включается?
Да, включилось, правильно.
Слышите нас, коллеги? Do you hear us?
Can you hear us, colleagues? If you can hear me, I will continue. Commodore Keman Khatri.
I'm pleased to be a part of this conference. I'm sorry that I catch Russian words very little, but I'm following the webinar. And I'm very grateful to you for introducing me for this session.
Да, конечно, мне очень приятно тоже.
We are also pleased to welcome all the participants of our webinar. Within the last 10 years, I was working on the design and work in the Shipbuilding and Ship Repair Technology Center. Many Indian colleagues can remember me. We worked together in the Admiralty shipyard. The tanker, fueling tanker, was built in the Admiralty shipyard for Indian Navy. It was built in 1995 and was commissioned in 1996. I was the chief designer of this tanker, supply tanker. And I'm really pleased to recollect that period of time. And when Mr. Jayant Patil, in his speech, mentioned design bureau that is designing the ships for Indian Navy, I recollected the conference in Delhi of the year 2014. The topic of this conference was ships of the future, ships of the next age. And at that conference, I was presenting a speech that consisted of two parts. First part was dedicated to our joint work on creation of building of dockyards in Cochin, in Visakhapatnam, where Shipbuilding and Ship Repair Technology Center was participating, which is called now Soyuz Project Verf. And in the second part of my report, taking into consideration the topic of my previous speech, I described the audience, the approach to the shipbuilding of the next generation, of the next age. And I was really surprised when one of the colleagues approached me, Indian colleague, and I recognize ex-naval attaché, Mr. Ramsey, and we were talking. We had a warm discussion. We recollected the period when he came weekly and controlled the construction of that tanker. And I would like to say that the topic of our today's webinar, which sounds as shipbuilding, Ship Nation is through the shipbuilding. Sorry, there is no sound again from the speaker. The interpreting is not possible.
Professor Kirill?
Unfortunately, there is no sound from the Russian side.
Okay. No, often the connection goes, I don't know.
Восстановились, да?
What's the screen?
Colleagues, do you hear us now?
Yes, yes.
Yes, okay. Можно это?
Да, конечно.
Я хочу, во-первых, еще раз...
I would like to welcome once again the commander, Herman Tekatri. Thank you very much for being here. We know about your honors and we wish you very best and success. And I would like to tell about Valery Kireev. You've heard that he's the deputy managing director of Soyuz Project Verf. This is our center for maintenance and repair. And he is also the director of the company Soyuz Project Verf. This is a part of the central bureau. So Valery graduated from our university.
Видно, но не слышно.
Не слышно. Сейчас будете слушать. Он выключится, по-моему, сам. Нет, у нас включен.
Включен.
А здесь стоит значок, вот сейчас включен.
Включено, да? Do you hear us, colleagues? Вы нас слышите, коллеги наши российские?
Yes.
Слышит переводчик, самое главное.
I can hear you.
Значит, я хочу вот о Валерии Кирееве еще сказать, что...
So I would like to tell about Valery Kireev, that he is an honored designer of the Russian Federation. He was awarded a very important order just for his service for fatherland. And he is in the management of key Russian shipbuilding enterprises. Unfortunately, the sound is lost again. I can't hear the Russian side.
Что такое? Нехорошо.
Давайте пока поменяемся.
Да, наверное, сейчас Сергей.
Да.
Один.
Тихо, Глеб.
Это сейчас Сергей, садитесь. Сейчас мы начнем.
Я заберу пока бумажки.
Глеб, спасибо огромное. И увидеть приятно. Не ходи пока.
Да не, я пока туда пересяду.
Так, флешка вот сюда, да. Сейчас мы да? Есть. Демонстрация экрана. Вот здесь share screen. Сначала нужно открыть вашу, да? Вот, и потом share screen вот здесь где-то есть. Да, вот здесь. Которая ваша?
Держите, там вам сообщение в WhatsApp приходит.
Значит, они все звуки говорят, что со звуком очень плохо.
А звуком хорошо, без звука плохо.
Да. В общем, говорят, что это всех раздражает очень звук. Сейчас, секундочку, так. Там все адмиралы гневаются.
Слайд-шоу.
Слайд-шоу, где вы слышите сюда?
Ага. Вот сначала.
Сейчас я хочу представить.
So now I would like to present one more speaker from Central Design Bureau Iceberg. This is Sergei Korneyevets. He's the principal specialist, and his presentation will be about floating power blocks, but on liquefied natural gas. Good afternoon, dear colleagues. Good afternoon, dear co-chairs. I present the part of projects related to floating power blocks from the Central Design Bureau that produce power on liquefied natural gas. This part of work started in Iceberg Bureau, taking into consideration the economic situation and understanding that consumption of energy will increase, and the main consumer just that has the main consumption of electrical power. These are the Asian countries. Their economies are growing rapidly, and this is around 5.5% per year. The main specific detail of producing energy on liquefied natural gas, this is high cooperation, and we provide the information on this webinar to our Indian partners, potential Indian partners, while creating power blocks and power systems. The scheme and operation of this project can be seen on this slide. So we organize the joint company operator using Russian and Indian investment, and also the cooperation between project universities of Russia, where we suggest to take the leading role for our enterprise, and in the construction part, this is joint work between shipyards, maybe that were presented today on this webinar. We saw their capacities, and we could do a part of works there. And a part of works can be done on shipyards
строительной корпорации «Звезда» в Большом Камне.
Звезда shipyard. What can be interesting here that you can announce now? Apart from generating with nuclear power plant, we can provide a wider range of capacities on liquefied natural gas. This is just a wider variety of opportunities to generate power, and we can provide and propose for 30, 60, and 100 and 150, and also 300 kilowatts per hour that we calculated and we provide the consumer. This is for 6 or 10 cents. Currently, this price is very attractive because the cost of 1 kilowatt per hour that is generated by solar power generators in Indonesia, like the general market, is 5.5 cents. For Indian partners, if you are interested in this project, we could provide and ensure some localization of equipment made by Russian producers. And we also can provide further intensive development in terms of preparing employees and specialists with the help of SMTU and also with the help of Krylov Scientific Research Center in St. Petersburg. The level of localization in terms of equipment produced in Russia it is possible within 35%. These are the main capacities that Central Design Bureau Iceberg worked out for power plants on liquefied natural gas. And the power plants are used for energy generation. We see our consumers in Asia and Southeastern Asia, and also thermal energy can be produced, but is not really relevant on that market. On this slide, you can see the power plant, 150 megawatts, and electricity is produced by generating on two fuel engines, and heat is converted into energy. This vessel can be done with the integration of LNG storage and also power plant in one sea object or separately. The decision is made by the customer, because when we divide these objects, we can provide the smaller embarkment of each, and it will help to place the vessel in different coastal conditions, and also the costs will be reduced for the coastal infrastructure. If we talk about submersive problems, if you don't see these problems and the designer doesn't see the problems, so we can significantly reduce capital costs, proposing the decision, the solution, where the power plant and the storage will be in one hull. The same project was done for gas turbine generators for heat energy, and this design solution in the capital costs is a bit more expensive than we are organized on two fuel engines. However, the average mass of power plant is much lower than generating with two fuel engines. In this slide, you can see the power plant for 300 megawatts. Here we calculate that current solution that was presented, that are presented on the market by Turkish companies, they are not effective. And of course, 300 megawatts, when we have 300 megawatts, it's easier to use gas turbines and also to utilize the heat and heat utilizers. This solution for today is one of the newest. The first object was done by the company Siemens, and only this year it was launched on SGT 800 turbines as an option for localization and using Russian construction or domestic construction. We've worked our local turbines 110M. Just general solution, general construction solution. This slide shows the sizes, the measurement of sea equipment. I would like to add some words that if our dear Indian colleagues are interested in such collaboration in this field, for today, for a power plant of 150 kilowatts or megawatts, we would be able to suggest some attractive figures as an object of investment. We have the share of capital costs to operational costs is 4%. This is a very good indicator compared to other ways of generating, where the capital costs at the beginning are very high. So we calculated just a typical placement of IPP contract during 10 years. And the investment returns is for 9 years, and annual profit that we call net income is approximately $19 million. When you invest $78 million, which is not bad indicators in the sphere of energy generation. Thank you very much. And now we will give the floor to the Center of Technology and Shipbuilding, Alexey Anatolievich Vasilyev. He is the head of laboratory of Science and Research Company Sudotechnologia. He will present the presentation about introduction of up-to-date Russian technologies during modernization of Indian shipbuilding and ship repair facilities. This center has very good connections and relations with Indian enterprises, and Alexei will present new elaborations of this Center of Technology and Ship Repair. Thank you very much for the opportunity to present. Good afternoon, dear friends and dear colleagues and dear partners. I am very proud that our center, this is the first presentation about our investigations, and I'm very proud that I will present it. So I was the technologist of several projects, and I worked on projects together with Indian partners. The first works that were done in 2006-2009 were related with the technology of ship repair made by Russian designers. This is the team. These were the vessels and also aircraft vessels. And we also delivered Russian equipment and also maintained it at launch. Another works that I conducted, that our center conducted, it was in 2018, and it was a new step. We've worked out new technologies, not of repair, but of shipbuilding. The ships 11-356 that were designed in the Russian bureau, but they will be built in India. And we've worked out not only the technologies that allowed to build these ships very easily and within 5 years, but also to implement on this shipyard the most modern technologies that can be used further in the future for building civil and merchant ships and any other equipment and devices of marine industry. On the slide, you can see the scheme of material flows, and you can see that it touched all kinds of production, and almost for all kinds of production, we suggested these or that principal new technological solutions, and we hope that shipyards will implement them in the near future. So we will start with metal flow, with producing the details, manufacturing the details, the components, the original Russian technology that we would like to suggest to Indian partners. These are just flexible details. So the core of this technology is that we make maintenance in the very narrow part of the detail with a rotating element. So this helps us to reject from producing very expensive blades, and we also can blend or can bend the details. And this is highly required not only in Navy ships but also in civil shipbuilding. And we also deliver these details, these components to Dubai and to Croatia. It was already put into operation. So when it is ready, we hope that this kind of machinery for bending the details, the components of difficult forms, can be used in other countries.
Another equipment we would like to offer is the automized line for cutting and marking of components made of profile. And it will be the line involving the robotized equipment with the laser cutting machine or another type of cutting depending upon the demand of Indian partner. Why? The cutting which is robotized seems to be better, the best one. Gas cutter cannot cut the edge of the profile so accurately as the robotized equipment can do. That's why robotized processing is one of the first directions where robotic equipment is introduced in the shipbuilding industry. And we hope that in Goa, robotized equipment will be used successfully in the nearest time. Next slide, please. On this slide, we can see the project of a new hull making workshop in Goa shipyard that has been built and is outfitted right now with the equipment, and we hope Russian technologies will be used successfully here. Now we move on to the second production, is the assembly welding production, assembling and welding processes of hull structures. The innovative solution offered to Indian side here is the idea of the rector of the University of Gleb Turichinov being realized jointly with our center is the hybrid laser arc welding technology for flat pattern sections. Together with Marine University, we have produced the test sample of the equipment. You can see it on the slide, and currently it is in the Marine Technical University, and it is used for training the students. And the production sample of such equipment we hope to see in Goa dockyard in India. The specific feature of this technology is that the flat sections produced with the help of this welding have no deformations, no distortions, which is especially important for the thin hull plates. For small vessels or large vessels, for those sections where the hull plates are very thin. So these thin plates are usually deformed, and particular laser technology allows to minimize these distortions. To cut the components for these sections, we suggest to use the laser cutting machine equipped with fiber optical laser and ensures the precision of edges and highest accuracy of the parameters. As for robotized equipment used for other processes, for example, for arc welding, we would like to use a robotized system involving automized assembling of structure and robotized welding. A robotized system is going to be equipped with the industrial vision that allows to define accurately the dimensions of the assembled structures before processing, and it can take into consideration all the allowances. Next slide. We also want to offer the automized line for welding, and it is minimizing the distortions. These structures are used almost on all the vessels, not so frequently used for warships, mainly for offshore and commercial vessels. So we offer this kind of equipment as well. This slide is presenting a general common view of the assembly welding workshop and the places where we suggest to install the new robotized equipment. Amongst a little bit unusual offers, we also want to suggest the original technology for titanium and aluminium alloy products production. Processing titanium components is the process that needs a special attention, especially to the cutting and welding. So we would like to offer the numerical control machines for the hydroabrasive cutting and special equipment for argon arc welding of titanium components. For example, for the ship's 11356, we have produced the hydroacoustic stations domes, but we can build different structures of titanium. That's why in this project we have foreseen the special part of the workshop for production of titanium parts and components. That was about the hull structures, but we could not skip the pipe production. Particularly among the achievements of our institute is the machine for pipe bending with induction heating. This machine was already supplied to India, and its new modification, improved version, will also be supplied to the Goa dockyard and other dockyards. Induction heating technology allows to bend the steels of big diameter with the highest possible accuracy. The machine is presented on this slide. Next. Apart from bending, we frequently face other operations linked to high labor consumption. And we suggest another automized machine, for example, milling machine to cut the openings with the diameter from 45 to 310 millimeters. Presented on this slide. Next, we also offer the original machine for cleaning of rust and dross from the outer surfaces of the ends of pipes, made of steel, copper, and aluminium. As for one of the most interesting elaborations is a computerized locational acoustic measuring system. This system allows to digitize the dimensions and the shape of the pipelines. Creation of such digital model of the pipe transferred into the control system of the machine allows us to produce the pipe during ship construction and during ship repair process. This is the system, the station that was developed in our center, and we offer it to our Indian partners. Another pipe processing equipment offered by us, a special automated stand for assembling of pipes with flanges. It allows to assemble pipes with different shape flanges in the workshop in compliance with dimensions according to digital model with the minimum errors that will minimize the labor, efforts, and maximum accuracy. And another crucial production important for shipbuilding is the galvanic coating workshop. Many dockyards in India and in Russia are located very close to large cities. For example, Goa shipyard is in the middle of the city, we can say. That's why the environmental safety issues are truly important and critical for us. That's why within this project, we have offered a modern chemical cleaning line that would ensure and comply with the most stringent requirements to the protection of environment and protection of human health. So this line is presenting such modification for Goa shipyard. Another feature of this dockyard is the availability of the outfitting workshops, processing thin metal and processing of non-metallic components, insulation, and wood, timber components. So for this workshop, we also offer the CNC machines, laser cutting CNC machine for thin metal plates and machines designed for cutting of timber, wood components, and insulation materials. As a conclusion, I would like to highlight that specific feature of Goa shipyard is the presence of electrical outfitting workshop, and we offer the modern set of equipment for modification of such workshop and the original loading system that will be installed at the outfitting embankment and would allow to perform the testing of the systems. Let me thank you for your attention and express the hope that many new Russian innovative technologies will be introduced in the Russian dockyards, in the Indian dockyards. Thank you, Alexey Anatolievich, for this wonderful speech and great offers to continue the cooperation with Goa shipyard. And now I would like to give the floor to General Manager of Garden Reach Shipyard, Modern Technologies in Shipbuilding, Mr. Commodore Fashar Sigupta.
Indian colleagues, do you hear us?
Can you hear us?
We call upon Commodore Bhaskar Singupta General Manager of Garden Reach Shipyard. Они слышат нас, нет? Да, должны слышать, да?
Can you hear us, dear colleagues? We request for representatives of Garden Reach
You are
Shipyard.
calling now?
Yeah, sure.
May I
Yes,
know who
please.
you are calling?
We are calling Commander Bhaskar Sengupta.
Yeah. Commodore Bhaskar Sengupta?
Yes.
Sir, could you kindly... Hello? Could you kindly
This is
come and-
Garden Reach Shipyard. Are you present there?
Commodore Bhaskar Sengupta?
Yes. Bhaskar Sengupta.
Sir, you are on the screen. Commodore Bhaskar Sengupta. Hello. Commodore Bhaskar Sengupta. Commodore Bhaskar Sengupta. I think Professor Kirill, I think he's not there. Professor Kirill?
Yes, yes.
Yeah, you may kindly now request another speaker, and we'll see in between.
Yeah, sure. We pass
Yes.
over to another
Yes.
speaker. Yes, Valery would announce.
Да, я хотел бы предоставить слово заместителю
Would like to give the floor to Deputy of Design Bureau Vostok, which is also a part of Shipbuilding and Ship Repair Technology Center. Cooperation in the sphere of designing of modern fishery and patrol vessels, with a further construction in the dockyards of the Republic of India. Mr. Ulashev, are you here? Good afternoon. Good afternoon. Thank you for this opportunity to speak. I represent Design Bureau Vostok. We have an experience of almost 65 years of operation, and we are responsible for designing of mainly fishing vessels and special purpose vessels. The team of our bureau has required experience and competences to design any objects. Our design bureau is using the new technologies on the basis of elaboration of 3D information models, and we are using the materials in our work, virtual reality, augmented reality tools. Technical level allows to take into consideration all possible requirements. And main direction is the introduction of modern technologies, which allows us to achieve a high result and optimize the supply timelines and designing timelines. Design Bureau Vostok is dealing with not only with designing process, but we also perform different type of expertises to reveal the compliance with norms, rules, and regulations, and work under the guidance of Ministry of Industry and Trade. The ideology of designing process is built on a 3D model. We develop the future project concept of the vessel, then 3D models goes through all design stages, starting from the sketch up to the production of relevant project documentation, and we also support the construction process. The offer to the Indian side is presented now on the screen. We would like to describe the recent projects developed by us within last 5 years. Fishing vessels are the construction of fishing vessels is developing as in Russian Federation currently, and we execute different projects and perform design, and we also perform the expertise, check the compliance of the projects with all requirements. So our design bureau is highly competent in the development of this kind of vessels. We also develop the other projects and I would like to describe the project of patrol boats that were developed by us within a recent period. You can see the freezer trawler on the screen. 80 meters is the length, 15 meters width, 3,500 ton is the tonnage.
Here you can see the fishing vessel diameter 58 meters length overall, and medium fishing vessel, refrigerating fishing vessel. The length overall of this one is 38, and the average fishing vessel 38.4 meters length overall, 506 tons. From what you saw, the projects that you saw, we can mention that all of them are different style and different design. There was a very tough work, not tough, but complicated work with the customer, and we took into consideration and accommodated all the wishes. The next project is the project of the patrol boat, fishery patrol boat. This is the vessel that serves for patrolling in fishing areas just to protect the rules of fishing. And the length overall is 65.9 meters. And the speed is maximum 21 meters. The rest vessels, patrolling vessels, have just much less water displacement, and full displacement is 72 meters. You can see that this vessel has armament. This slide presents the patrol boat, the length 23.5 meters length overall, made of composite materials. And this is the project of the vessel, 3140. The length overall is 33.2 meters, and the armament can be placed there as well. Also, we can see the patrol boat. Overall length is 33.5 meters. The project of the patrol boat, 43.00 overall length. And our last design is the project of unmanned surface ship. And we've made 3 modifications: patrol boat, just to fight subversive devices and also attack ship. That is all. Thank you very much for your attention. Dear colleagues, can you hear us? Thank you very much, Alexander, for your interesting presentation. I would like to reiterate the same as I told at the beginning of our session. I said that we've mentioned the direction connected to the future of shipbuilding and the future of how ships look like. We heard it in the presentations of Gleb Anatolievich, Makeyev, and also in the presentation of his colleague Sergei Anatolievich Kornevets, when they talked about floating power blocks with different systems of power generation. And we also heard this in the presentation of Alexei Vasilyev with his suggestions to develop Goa shipyards. And also we've heard it in the presentation of Mr. Ulyashev in terms of cooperation in the area of fishery vessels and patrol boats that were made by Design Bureau Vostok. I would like to mention and reiterate at the beginning of our session that talking about the conference that we had in 2014 about the ships of a new generation, it took place in New Delhi, and we met with former Navy attaché in Russia, Mr. Ramsey, and with the interest we remembered our mutual friends that we collaborated during the work on projects. And these friendship and friendly relationships that are between specialists of Navy in India and in Russia, and Russian scientists, Indian scientists, they are equally important in terms of, for the topic of our conference, as some business contracts. Of course, they go together, and I would like to thank all the participants and all the speakers to wish all the best in our conference today and tomorrow. And I would also like to give the floor to co-chair of our second session, Mr. Commodore Hemant Kantri, to make comments on our today's session, number 2. Please, Mr. Khatri, you have the floor.
Pasiva, very good afternoon to all of you. Please confirm, can you hear me?
Da.
Okay, thank you so much. First of all, I would like to compliment and thank the organizers for planning this webinar, which is very useful and can have a spin-off in our mutual business. Second point is it is timed at a very appropriate moment when we are going to have annual Indo-Russian summit in the next week with the visit of respectable president of Russia, Mr. Putin, arriving to India with his delegation, and we are going to have a lot of summit at Delhi. So this is really timed at a very appropriate moment. Coming to this session, before I say, I would like to thank again Master of Ceremony, Mr. Udit Banerjee, as well as Professor Kirill for giving me an opportunity to participate and to co-chair this session. Moving on to the papers, the first paper which was on floating power blocks, FPP on nuclear power plant. It was, honestly all in Russian. Even the slides were in Russian, so I couldn't actually make any appreciation of it. So I'll skip that. But the second paper, which was on FPP on LNG, floating power blocks on liquefied natural gas. That was very interesting.
По второму он сейчас говорит по СПГ, да, по вашему, Сергей.
Okay, can I continue?
Yes.
That paper was very interesting, and the vessels are very useful. But my thought is it was presented very well. There was a lot of information, good design and good presentations. We can actually talk about it in the defense exposition, which is going to take place in India in February at international level in Ahmedabad, Gujarat. I have only one issue on this paper, one clarification that, utility of it, it can probably be utilized in the islands of India, because in the mainland in India, there is no shortage of power. Plus, we are going into, because of carbon footprint and COP26 summit, we are going more on to solar energy, and conventional power rather than, this. So utility, I find in India right now, we have power surplus in many states. So where do we use this floating power block is something that we need to study and examine. And as I said, in the Defense Expo, probably it can be presented, and if anybody needs, we can look at these options. I can, as of now, thinking only of the islands of Indian Ocean. Paper 3 was again a very, very interesting paper, particularly from my shipyard, the Hindustan shipyard point of view. I suppose I am audible, though the picture is missing. Yeah. The third paper, which was introduction of up-to-date, Russian technologies during modernization of Indian shipyards for shipbuilding and ship repair. This was a very useful paper. In fact, my shipyard has got many workshops designed and set up by the Russian industries. I have got pipe bending machines, chemical cleaning bay, and many such things set up with the help of Zvezdochka shipyard of Russia. Because here we have been repairing the submarines for last 25 years with the help of Zvezdochka shipyard, and now under OSCA, United Shipbuilding Corporation. We would like to actually welcome, as a Hindustan shipyard director, I would like to welcome the professor who talked about this technology, and kindly visit HSL. You can send an email to us. Your visit will give an opportunity to examine what all technology we can adopt. And right now we are in the process of upgrading our shipyard. We are investing a lot of money to set up new workshops, new machines, the slip bay, jetties, and Goliath crane. So it's a right moment, and very appropriate paper, very useful to most of us. And Hindustan shipyard being involved in Russian submarine repair, Russian ship repair, and commercial repair, I think it's a very good tie-up that we can have. My last bit on the fifth presentation, of course, Mr. Sen Gupta was not present, so skipping to the next paper, which was by Vostok, by JSC, SST, which was on cooperation in the field of fishery industries and patrol boats. This was a very well presented paper, beautiful design, very efficient vessels, multi-purpose vessels. It's of a great relevance to us, because in India we have a project Sagarmala running. We are going in for many more crafts on the fishery. I think as far as the fishery is concerned, we can have a MOU with the Vostok, and we can together present it. I'll make a presentation to our Ministry of Fisheries, and once we get funds, we can look at an option of constructing these vessels at Hindustan Shipyard Limited. Similarly, you have presented many multi-purpose vessels, whether it is surveillance vessel, it is unmanned vessels, patrolling vessels, many other applications you have suggested. I think there is a scope of cooperation and construction in India on all these vessels, but this will require a little more detailed discussion between you. You have presented the paper and Hindustan Shipyard Limited. So maybe Vostok and HSL can again sign an MOU, NDA, and we can take this forward. So I will sum it up by saying that this was a very interesting, a very useful session where we have many takeaway points. And I would like to compliment all the authors who presented the paper and would like to appreciate and give them a big thank you, Persiva, and appreciation from my side. Thank you so much.
Хатри, я хотел бы вот еще дать слово.
I would like to give the floor to Sergey. Sergey Korneyevets, who presented about the NLG power block, floating power blocks. He would like to comment on your remarks that you mentioned in your speech. So, Sergey, the floor is yours. Dear Mr. Khatri, thank you very much that you appreciated the presentations of Central Design Bureau Iceberg in terms of power blocks generations on LNG and nuclear power plants, and of course your comments on renewable energy sources or green technologies is very relevant. And of course, we need to talk about the point of application. When we talk about solar energy, of course, it's great when you have free area, free territory that can install as many solar panels as they can give to have 300 megawatts. And I can say that to get 300 megawatts on solar panels, you need around 100 football pitches approximately. Taking into account the climate of Southeast Asia, of course, you know, there's a typhoons, monsoons. Of course, you need a stable surface. And it is often implemented on a lake or water basin. Of course, it can be implemented there, and solar power plant with a capacity 60 megawatts. It is in Indonesia in a water basin. And as you said, the application in liquefied natural gas, these are definitely islands, and the islands where natural disasters are an important factor. These are tsunami, earthquakes, and volcanoes. And these are coastal points that are remote from sea coast up to 200 kilometers. These are the conditions where LNG power plants are very effective. And our design bureau calculated this, and regarding the parameter such as logistic, how to bring LNG. In October, a portion of LNG will be delivered to, it was delivered in India, Marshal Vasilevsky vessel from Port Sabet, LNG deposit. This is far north of Russia. And I don't know, unfortunately, the final point in India, but it was delivered to India. And regarding the region that we talk, the Southeast Asia, there they have their own capacities that produce LNG. In Indonesia, as well as Malaysia and Australia. And there are some common joint enterprises that are located in Russia, in Far East in Sakhalin Island. So we invite you, if you are interested in this topic, we invite to work with the contacts, Indian shipyards, to study the opportunity to work together and to collaborate together, because the opportunities to make shipbuilding works, there are much more opportunities in warm climate than in Russia now. I think now we have snow behind the window. Thank you. Thank you very much, Sergey, for your presentation. Dear colleagues, dear Indian and Russian colleagues, thank you very much for your interesting presentations. We finished the session number 2, and now we move to session number 3. It is called Modern Shipbuilding and Marine Technique. Co-chairs of the sessions are the Dean of the Faculty Shipbuilding and Ocean Technology, Professor Timofeev, and Rear Admiral Rakesh Bajaj.
Олег подключился, нет, Олег? Да, спасибо большое, Валерий Николаевич, за...
Там открыто. Так,
садись, Олег, сюда прям.
Уже все? Да, молодец.
Так, сейчас. Мы сейчас посмотрим, что тут можно включить. Здесь, наверное, этого нету.
Скажи, пожалуйста, что здесь надо делать?
Сейчас мы разберемся с этим. Сейчас я покажу это адмирала. Сейчас, дальше, секундочку.
I'm going to share my screen right now.
Это не адмирал. Сейчас вот будет вот здесь. Я, наверное, 2 слова скажу, если индийские коллеги не будут возражать.
I would like to say a few words, if my Indian colleagues do not mind. I have a brief CV of Rear Admiral. This is a very famous person who was commanding the Mazagon Dock Limited. And he started working there in the year 2009 after 34 years period of service in Indian Navy. He retired in the year 2012, and afterwards he was always working in the industry at different levels. His last appointment was the head business development of Reliance Defense and engineering companies. Rear Admiral Bajaj is the engineer, and he has graduated the IIT.
I don't know full name, but this is a famous Indian university.
A famous Indian university. He has also an MBA, and he served in various places in Navy, also was involved in strategic planning as a director of fleet maintenance and as assistant chief of material, information technologies and systems. Within 4 years, he worked in the research and development establishment of Ministry of Defense and worked in the creation of the data network for new generation of naval ships. He has 9 years experience as a manager and deputy general manager, as well as additional general manager of Naval Dockyard in Mumbai. He has been the instructor at the training establishment for Indian Navy, and he commanded this subdivision in the year 2005-2006. He also served on submarines and aircraft carriers. Rear Admiral Bajaj was awarded with a number of governmental awards by the President of India in the year 2005. He has also been awarded by the Commander-in-Chief of Western Naval Command. That's what I wanted to say about Rear Admiral. And I would like to say a few words about Oleg Timofeev. Oleg Timofeev is a famous shipbuilder. I'm proud to highlight that he has graduated from our Marine University with excellence. Applied mathematics was his diploma. You know, it's important topic, and he was a PhD student on the automated systems for design, cut of hull structures of transport floating docks. In 2002, became the Doctor of Technical Sciences on prediction of reliability indicators of ice belt structures. So his direction is linked to polar technologies. In 2015, he received the MBA executive diploma from the highest management school of St. Petersburg State University, large, big St. Petersburg State University. From 2006 up to 2019, he was a chief researcher and head of department and head of subdivision of civil maritime technique. He was a deputy director general for shipbuilding and marine techniques of Krylov State Research Center. Starting from 2020, Oleg Timofeev went back to his university, and he's now a dean of Faculty of Shipbuilding and Ocean Engineering in SMTU. He spent a lot of time, long period in our university before he went to the production. He also worked in the Central Research Institute #1 of Ministry of Defense of Russian Federation. He also took part in more than 180 projects on shipbuilding, shipping, and marine techniques, contracts with customers in Russia and foreign countries. In 1992, from 1992 till 2006, he took part in more than 15 expeditions in the Arctic and full-size ship trials. Oleg Timofeev has about 160 publications, 2 monographies and 2 textbooks. He is also the deputy chairman of the Science and Technology Council of the Russian Maritime Register of Shipping, and he holds the title of Honorary Shipbuilder of the Russian Federation. Now I would like to give the floor, If you don't mind, dear Indian colleagues, to give the floor to co-chairman Rakesh Bajaj.
Good afternoon, ladies and gentlemen.
Сейчас мы к нему подойдем.
So we have 6 papers in this session, starting with the first paper by KSRC. Can you hear me?
Слышим, yes, we do hear you.
Yeah, so we paper which is in field of ship electrical propulsion systems by R.U. Atkov, Deputy Director General.
Это у нас Очков. Да, Очков. Это первый доклад у нас из Крыловского государственного научного центра.
First report from Krylov Scientific Krylov Center, and it is going to be presented by Rostislav Atkov. The developments in the field of integrated ship electrical propulsion system. Rostislav, are you with us? Good afternoon. Good afternoon. Naumov Andrei will speak instead of Rostislav. We are glad to see you and listen to you. Can I start? Yes, please. I would like you to confirm that you can see the screen. Can you see the screen? I could not test it, so...
Нет, так я сейчас войду, наверное, share screen, да? Что надо сделать, скажи. Он есть? Он сам, да? Я понял.
Все видно, экран транслирует.
We can see the screen. I will speak English to make it more convenient.
Good afternoon to all. This is a brief presentation on the experience of Krylov State Research Center in development of electric propulsion systems and integrated electric power supply and management systems. As you know, well, this is one of the important trends in the shipbuilding, and in that part of the shipbuilding which deals with power supply. Having full or hybrid or auxiliary electric propulsion. It provides for better fuel efficiency, it allows better maneuverability of the ship, especially at low speeds, and provides several other tactical and technical advantages. Apart from that, it also allows to follow the trend which has been building throughout the past several years, decreasing the carbon footprint of a ship. We have had an experience of developing electric power propulsion systems for a variety of maritime platforms, ships and stationary platforms, as well as a general fundamental research into how the systems should be built in accordance with the ship assignment and operational environment. Well, generally, as well, the ship electric propulsion system may be presented as follows. There's a primary power source, which may be a diesel engine or a main gas turbine. There's an electric motor, which connects to the shaft through reduction gear. And there are different types of arrangements of how this electric propulsion motor may be connected to the shaft, whether it be through reduction gear, be on the same shaft, or be connected otherwise. Different arrangements serve different applications. We, of course, considering electric propulsion systems, have to think also about the opportunity it provides to create an integrated electric power supply. That is, the electricity generated by the primary power sources may be distributed not only to the auxiliary or full electric propulsion system, but also to all other systems which use electric power as a source, or customers, as we call them sometimes. Well, the biggest advantage of this is, of course, in the reduction of mechanical connections and opportunity to be flexible in provision of power supply to the different users, well, depending on the operational situation. Well, here we have all the elements which may or may not be in the entire system, like, well, as I said, primary power source, main switchboards, transformers, frequency converters, and so on. We have worked extensively on the development of the concepts to analyze which ships are better served by which kind of electric power propulsion system, or a full electric power propulsion system with integrated power control. Here, well, you see general views of such types of ships and the types of electric power propulsion systems and full EPS which are built on them. This is, of course, a very general idea, but it was fully applied to the practical ship designs on which the electric power propulsion systems or fully integrated electric power supply systems have been implemented. In gray, you see the ships which have been built with EPS designed by and made by us, because I will mention that later. While Krylov State Research Center also participates and makes elements of the systems itself. And in light green, you see the ships which are still under construction or under testing. So, well, what we are talking about is not just theory, it's the practice, and practice proven by successful trials. Krylov State Research Center, as I said, has a facility to build and, more importantly, to test the electric power supply system components. We have a 5 megawatt test facility and a 40 megawatt test facility. Well, here, generally, there are major characteristics, and the types of the equipment which may be tested are propulsors, transformers, switchboards, which we make, frequency converters, which we make, and, of course, propulsion motors. We have developed a general view on how how a cooperation between the Russian companies, including and having a leading role, the KSRC, may have with Indian companies. This slide generally presents the share of works between Russian companies led by KSRC and Indian companies, and we have been looking for a partner, single partner, which could be sort of a leader in cooperation of Indian companies, which could help form this or create this international Russian-Indian cooperation in building or setting up production plans for jointly developed and jointly built electric propulsion systems for various types of ships built either in India or in Russia. Well, as I said, this slide shows the possible share of works and responsibilities in a very general way. But as I said, well, the important thing is to find a proper partner. Well, that's briefly all. Thank you very much.
Большое спасибо.
Thank you so much for this interesting report. This is the report from Krylov Center.
So let's listen another presentation by Mr. Jethu Srikumar, the senior consultant and director Vine Mobility. Unfortunately, we do not have the topic of the presentation. We hope to hear the topic and the presentation. You are having the floor.
Есть автор?
Пожалуйста,
Is here the presenter from the company Vine Mobility? Professor,
do we have One Mobility present?
Что там в чате? Может быть, в чате?
Yes.
Well, we are looking forward to listening to this presentation.
Sure.
Сейчас Шу сказал, так что будет, наверное.
Так, мы вас только что услышали. Вот появляется презентация, да?
yeah, we can hear you. Here we see the presentation.
Hello. Hi. Good evening, everyone.
Да, спасибо, пожалуйста. Большое спасибо. У вас 15 минут.
You have 15 minutes for the presentation.
Мы видим вашу презентацию, правда, в небольшом
We
масштабе.
see your presentation, but it is very short. It's very small.
Thank you. So myself, Jittu Sukumaran Nair. I'm a chief consultant to Hindustan Shipyard, and I'm a founder of Van Mobility, which is a startup, which is an Indian government accredited startup. So I'm going to present today is an ultra luxury expedition cruiser for sailing in the Arctic and Antarctic ship. So this ship is designed and developed by Van Mobility and Rolls-Royce, Norway. So it's been over 2 years. The ship is developed together with Rolls-Royce, Norway, which is now called Kongsberg, which is taken over by Kongsberg. So the ship is designed and built in a very efficient way for reduction of carbon, sulfur, NOx, increase of the speed. And we have already seen in the last presentation about diesel electric propulsion. So I'm just taking over to a few of the pictures. So we named this ship as Ferrari on the Seas. So this ship is designed for Arctic and Antarctic. This is classed under DNV, Polar Class 6, PC6. The main overview of this presentation is to go through the capabilities of the ship, hull optimization, speed prognosis, fuel consumption, range of the ship, and of course, this ship will be one of the best ships in the world to have 15 megawatt of batteries and fully operation on LNG vessels. This vessel is also having DP capability for dynamic positioning. The main particulars of the ship is this is one of the biggest and the largest ship in the world to be ever built. It is 193 meters and the breadth is 28 meters. These are main capabilities. The ship is fully operational on LNG and it can run on battery for 4 hours completely. Passenger count 299 passengers. Again, this is fully built for Arctic and Antarctic. Again, this is a diesel electric propulsion. It has 2 by 6 megawatt of azipods from ABB. It has silent thrusters. So when you are in the water, the thrusters are really silent, where the passengers have the complete comfort on the ship. So less vibration and low noise. So these are the specialities of the thrusters being installed on the ship. And the next specialty is that it has 15 megawatt of battery from Corvus, Norway. This is the complete system overview of the ship. It has 4 by 5 megawatt of Wärtsilä engines. It's dual fuel, it's LNG and diesel. It is a 6.6 kV main power switchboard, which is connected to the batteries. You can see here, it's 15 megawatt of batteries. On the azipod side, you can see it's 6 megawatt, 2 azipods.
Sorry to interrupt, Jitu, your full screen is not coming. It is coming very short. Can you just look at it?
So what about now, sir? Is it clear?
No, very small screen is coming. It is not covering the full laptop screen. If you are
No,
sharing.
you can pinch it out. You can increase it at your level.
Yeah, now perfect. Now it is better. Now full screen is there. Thank you.
Okay. Yeah, thank you, sir. So I'm just repeating this slide again. So this is the complete system overview of the ship, featuring 6 megawatt of Wärtsilä dual fuel engines, LNG and diesel. It has 15 megawatts of battery. It has silent thrusters, that is the bow thrusters from Rolls-Royce. It has 6 megawatt of 2 azipods from ABB. Hull design and optimization. So this ship has been designed with a lot of care for, to increase the speed. So it has, it's been model tested for 18.6 knots in Norway. The bulbous bow optimized for economical speed for 14 to 16 knots, and the max speed is 18 knots. And you can see the slender skirt featured with round keel. These are some graphs showing the maximum speed of the vessel. So 18.97 is the proved model test speed of the ship. Again, fuel consumption, this vessel is fully run on LNG. So again, major challenge of passenger vessels is more speed and more fuel consumption, running on heavy oil or diesel. So this fuel is fully on LNG, and this will reduce 40% of fuel, which is good for the commercial purpose. And LNG, of course, will reduce the carbon footprint and reduce the pollution. So we are focusing on environmental friendly, which will reduce the carbon footprint. These are again graphs showing fuel consumption, different fuel consumption at different scenarios with diesel and LNG. Hopefully, I will be sharing this presentation to you. So we have given a comparison with fuel consumption for diesel as well as LNG. This is a fuel consumption combination of diesel and LNG. This slide shows the battery operation of the vessels. So nowadays, Europe, Norway, Greenland, Iceland. All the Arctic and Antarctic is very strict on the pollution side. So it is very strict that vessel should be operated on LNG or on very low sulfur fuel. So we have designed the vessel with 15 megawatt of batteries. It can sail for 4 hours just on the batteries. At 18 knots, it can sail for 1 hour. So the vessel is fit for Lakers and all the parts of Norwegian areas and Greenland and Iceland. Now, why dynamic positioning? Dynamic positioning is normally used on the offshore vessels. We have incorporated in the cruise vessel. Without anchoring, without putting the anchor into the sea, we use dynamic positioning so that the vessel stays stable, station keeping capability. And so we don't need to use the anchors. So we have a 700 meters submarine on the ship. The submarine can be lowered into the sea by the use of dynamic positioning. So again, weight estimation for increasing the speed. So passenger vessels are weight critical. So if the vessel is calculated by using steel, so we have from the main deck or above deck 9, we have complete aluminum for this ship. So during the basic design phase, we have larger equipments, everything has been calculated. And from the main deck, that is deck 9, we have used full aluminum for the ship to reduce the weight and increase the speed of the ship and efficiency for the ship. Finally, these are going to, as I said, this is the most ultra luxurious ship in the world to have 3,000 square feet cabins, to the smaller one is 400 square feet cabins. Master suites and so on. These are some of the 3D imaginary drawings of the suites, which is again designed by Bentley, Bugatti. So the cabins are named as Bugatti suites, Bentley suites. Some of the exterior of the vessel. The vessel features with infinity swimming pool. All the cabins are with balconies. So with this latest design of this, we are sure that all the new owners and will be reducing the carbon footprints. Thank you.
Да, большое спасибо за доклад.
Thank you very much for your presentation. It was very interesting for Russia, building of such ships. It's really extraordinary.
Начали строить тоже круизные.
We, however, started to build the cruise ship in 2021. We launched the first ship into operation. It was river ships, but the exchange of experience with Indian colleagues is very interesting. Thank you very much. So we announce the next presentation. This is the presentation from the Russian side. The concern Okean Pribor, development of technologies of the concern Okean Pribor in the field of search and survey systems. Okean Pribor, are you here? Yes, Seleznyov, Deputy.
Большое.
Это
This
заместитель
is the head of
директора.
Priority Technological Direction and Deputy Director General.
Уважаемые
Dear co-chairs and dear participants of the webinar, I'm honored to welcome you here on behalf of Concern Okean Pribor. I welcome Indian and Russian colleagues. Our enterprise is the oldest and large in the field of acoustics, and we have very tight relationships with Indian colleagues. And we have a specific reputation, very good reputation on this market. And now maybe it is time to collaborate in civil shipbuilding as well. Hydra acoustics is a field where the border between military and civil tasks are very mixed, and the same equipment is used for different tasks. So today I would like to present you one of our technologies that can be really effective to solve various tasks. Can you see the presentation? Dear colleagues, can you see the presentation?
Еще нет, не видна. Сейчас она грузится не так быстро.
Нет.
Загрузилась?
Can you see the presentation?
Тогда, видимо, какая-то техническая накладка. Наши действия.
So probably there is some technical problem.
Демонстрация экрана надо включить. Вот это share screen.
Для нас это тоже один из первых опытов участия в вебинаре.
For us, this is one of the first experiences of participating in the webinar, so please forgive us for this technical problem.
Появилось что-то?
Can you see now?
Да, теперь видна ваша презентация.
Now, yes, we can see the presentation.
Отлично, тогда начинаю рассказывать. Итак, предмет.
So,
Предмет мобильные комплексы мониторинга поверхности дна.
we will talk about mobile complexes over bottom surface monitoring. So it is designed to collect information about the soil of the bottom, also to study different objects and to solve engineering tasks such as looking at the submersive parts of different devices and also to for implementing the pipelines underwater. This equipment can be set on ships up to 10,000 tons for different purposes, or up to 400 tons of displacement. So this complex has a flexible configuration that consists of a software program, the core, and also the navigation equipment that can be adjusted according to the customer's needs. So for today,
Ну вот коллега, который обеспечивает, он, да.
Зайдите в меню «Показ слайдов».
So they help to show slides, slide demonstration.
Есть? Коллеги, видно?
Can you see colleagues now?
Коллеги, видно?
Видно на полном экране и в режиме показ слайдов надо.
Пока видно только экран PowerPoint. Надо нажать показ слайдов, и чтобы весь экран был.
So they explain how to start slide demonstration.
Почему-то нет.
Ну, давайте дальше пойдем.
Ну,
пока у
ничего
нас
страшного,
появится.
давайте так, ничего. Видно все равно.
На следующем слайде представлены
So on the
решения.
next slide, we present the tasks. I've mentioned them already. So we suggest not the whole complex, we suggest the technology that has a complex character. It helps to plan, survey operations depending on the characteristics of the water basin. It helps to put the vessel on the gulls just to further shifting.
Игорь, надо вернуться в показ слайдов и нажать еще.
So sorry for disturbance, just they want to manage to set the presentation demonstration. So yeah, now they return.
Вот я нажимаю сначала. У нас все идет.
Так что давайте.
Сейчас, скорее всего, не будет показывать. Они могут нажать, вот там квадратик такой сверху, видите, где крестик, квадратик и черточка. Пускай на квадратик нажмут, они в полный экран его откроют. Скорее всего, из-за этого.
Право, квадратик пустой.
Может, пусть он как показывает.
Да нет, ну, нет, листаться будет просто стрелочкой.
Стрелочкой, и все.
Вот сейчас мы на третьем слайде, видим ваш третий слайд.
На третий слайд.
Ну, можно попробовать стрелочкой, да, пойдем на четвертый слайд.
Игорь, не надо нажимать показ слайдов, поскольку...
Я просто раскрою на экран. Видно?
Да, попробуйте.
Да, давайте раскроем. О, отлично.
Все. Пошел дальше. Итак, мы предлагаем...
Okay, we suggest the technology that allows to plan the operation, to keep the vessel in the right position and match the results, taking the information about 3D bottom and the characteristics. The complex is presented on this slide. It includes the echo sounder that allows to define the depth of the place, navigation system that allows to define the coordinates of the place, the winch, which is also a part of the complex, and the software and hardware complex that ensures its work, its operation. Next slide shows the modification mounted on the boat. Boat is a part of the supply. Location of equipment on the boat is shown on the next slide. We can see here special openings, special holes that allow to fix the antenna, to lower down the antenna, and there is a fixed winch allowing the transportation of the echo sounder. Location of the set of equipment on the vessel is presented on this slide. It is mounted, the entire equipment set is mounted in the container. Hydroacoustic antennas are installed on the piles along the board. Operator work, please. The echo sounder is designed to search for the goals located on the bottom, evaluation their dimensions and location. Here you can see the characteristics of this equipment and the frequency of ultrasonic hydrolocator. Hydrolocator operation is presented here. On this slide, you can see the tasks solved by the equipment, allowing to define the length of the equipment revealed on the bottom. Here is the task to define the height of the object that allows to find the objects above the goal, above the target. Here we can see detailed characteristics of the revealed objects. Another mode of operation is presented on the next slide. The set of the complex, different frequency, low frequency, and all the performances are presented on the slide. The type of this echo sounder is not only to define the soil, but also to reveal what's the type of the soil. This image shows the way it's done, the sand and the clay layers in the surveyed zone. The set of equipment includes the multi-beam echo sounder. Its characteristics are presented on the next slide. The results of work of multi-beam echo sounder are presented on the screen. Single beam echo sounder, its purpose is to define the surface of the seabed. The characteristics of the echo sounder are given on this image. 200 and 115 kilohertz are the frequencies. These are the results of the work of the single beam echo sounder, the system of inertial navigation and satellite positioning that allows to fix the ship in the position in the process of work execution. Hydroacoustic navigation station with ultra-short base is also there, which allows the navigation connection. Measuring of the sound tool, its task is to give the accurate measurements of sound speed and use it with the proper characteristics. Underwater, controllable complex allows to perform the additional survey of the revealed object and receive the image. Here are the results of the research of the survey. The technology of work execution, as I've mentioned before, is presented on the next slide. First step, defining the task, laying the route, depending upon the conditions of work. In the process of work, the vessel is positioned in the proper location, and the result of the work is a 3D image of the bottom of the seabed. Planning of the survey work is presented on this image, and survey is performed in compliance with the task which was set. Processing of information. This is the real pipeline located next to Sochi city, so the quality of the image is quite high. I would like to show a few real examples when this complex was applied. This is a serial production and produced for local market, used successfully in Russian Federation. Within few years, there is a state program going on in Russian Federation dedicated to the search of vessels that sank in the course of Second World War. The majority of the objects revealed within this program was revealed with the help of this complex. On the slide, you can see the aircraft that sank in the course of Second World War. It was revealed with the help of our complex. Next slide represents the vessel that was lost during the Second World War, and its length is up to 16 meters, and dimensions were detected with the help of our complex. When necessary, additional survey is performed. The survey is performed with the help of the television video recording equipment, and clear image is received with the ability to classify the object. What would we like to suggest to Indian partners? We respect the position of Indian side to focus on the production, on the local production. So we can not only supply this complex, considering the program Make in India, but we are ready to discuss the joint development. I think it might be interesting to use these complex abilities for the autonomous, independent underwater equipment, unmanned underwater objects that will help to perform the survey and investigation underwater using the innovative technologies of Russian scientists and Indian scientists. So we think that unmanned vessels with hydrographic equipment could be useful for these purposes. Thank you very much, Okean Pribor. That was a very interesting report. The problem of searching of the objects on the bottom, on the seabed, and global survey of the seabed is an important task because we have a lot of objects that sank, and we can use the sea as a kind of industrial environment. Thank you very much for this report. I hope you will continue your contacts and cooperation with Indian colleagues. Thank you. Next report that I would like to announce is the report from Indian side. Commodore Ranat Das, Director of Marine Research Center, Network Center of Underwater Location, connection to the shipbuilding. The floor is yours, Doctor.
Dr. Das, is he present?
Yes, I'm there.
Yeah. Thanks.
Thank you so much for this opportunity. My seniors, Admiral Bajaj, Commodore Mukesh Bhargav sir, and many other seniors from the Navy are also here. Thank you for this opportunity. I'll move to my presentation.
Спасибо, мы презентацию видим. О,
Can you see my presentation?
Yes, we do.
Отлично, да. Thank you very much. We can see your presentation.
So today I'll be talking about the underwater domain awareness framework that we have developed. And I will talk about that part of the underwater domain awareness framework, which is more relevant to the shipbuilding and the ship technology. Just to give you a sense of what we have been doing, I'll just try to connect up and how the underwater domain awareness or the UDA framework is relevant. Now, in terms of the 21st century new global order, one can see that the larger part of the maritime interactions are now happening in the tropical waters. I mean, India-Russia cooperation goes back many decades, and we in the Navy have been part of Russian technology, and we have operated and we have had ships. But there is a fundamental difference in the way the Russian technology has been developed and the way we would like to operate. So there is, I think, a bit of customization required, and the cooperation or the main agenda of this kind of seminar is well served if we can add value to the ongoing efforts. Now we talk about this Indo-Pacific strategic space, and the larger strategic cooperations or strategic interactions are also focused on the Indo-Pacific region. But a very important aspect is that the entire Indo-Pacific strategic space is spread across the tropical waters of the Indian Ocean and the Pacific Ocean. There has been some amount of work that has happened in the South China Sea or the Pacific part of the Indo-Pacific, But the Indo part of the Indo-Pacific, I think, requires a whole lot of effort in a strategic context as well. And in that sense, I think this cooperation can bring a lot of value. Coming specifically to the Indian Ocean, I think there is a lot of interest among the global communities, and a whole lot of extra-regional powers are also maintaining the strategic presence in this region and deploying their strategic assets. But this problem of, or the challenge of our sonars not behaving or not performing in the tropical waters is something we need to focus on. And it has to be focused on all kinds of perspective or all kinds of dynamics, right from the technology, science and technology aspects, and also from the perspective of how we can deploy them in the most optimum conditions. The increasing maritime activity is also leading to a whole lot of acoustic habitat degradation. I mean, you can see these kind of scenario more often now than before. And the sustainability aspect is something which is getting challenged more and more. So again, the UDA framework looks at all these aspects in a more comprehensive manner. And sometimes, the larger part of the underwater technology happened during the Cold War, when security was given the topmost priority and there was no questions asked. But today, I think in democratic setup, it is becoming difficult to kind of sustain that kind of a political viability. It is not only the seas, but you will also see a lot of freshwater crisis. The shortage of freshwater for domestic usage. I mean, in India, I can say there's 20% shortage. So the water resource management becomes a very, very critical area where, again, underwater domain awareness becomes important. And again, cooperation on these aspects can be important. Water quality management, again, there are a whole lot of issues in terms of water quality also. I mean, both chemical and biological contamination is becoming more and more pronounced. It may not be sabotage, but that also possibility is there. I mean, we are just going through the pandemic phase, and even sabotage cannot be ruled out. But a lot of things are because of neglect or lack of understanding. Now, the maritime domain awareness framework became quite popular in the strategic interactions or strategic discourse. After the 9/11 incident in the US, the global community woke up, and the US strategic community was driving this MDA term in a very, very aggressive manner. And probably in the Indian Ocean or the Indian subcontinent, it was the 26/11 incident. But my worry with that is that it remained an event-driven and a security-driven formulation. So the participation of the other stakeholders, where I would consider blue economy as well as science and technology, and certainly the environment and disaster management to be important stakeholders. There is always a fear of data security or classified nature of the data. The security establishments are not willing to cooperate with others. And because the blue economy doesn't participate, so there is not enough of resources coming in terms of doing more research. So how do we build a framework which is more inclusive is a concern. I mean, just to quickly tell you who are the stakeholders, it's very, very self-evident, and all of them need to participate. Pooling of resources and synergizing of effort is something we cannot escape. Maritime security, it is not just external security, but also internal security. How do we deploy our underwater assets in a more effective manner? If we do not get good sonar ranges, or the acoustic survey that we carry out, if it is not good, how do we deploy them effectively is a big concern. And internal security is another big issue. Submersibles are becoming more and more sophisticated, and they can really, and the whole asymmetry of such disruptive technologies can create havoc. Blue economy, oil security, the Indian Ocean is very, very important, but there is a lot of mischief that can happen. There are various dimensions of energy security, has a underwater connotation. Food security, I mean, increasingly we are looking at the sea. Fishing is unsustainable, bycatch is huge, very unorganized, and a whole lot of issues in the fisheries. Again, underwater domain awareness can regulate this better, but it requires a lot of technology to come in. Deep sea mining is becoming very, very important. again, unless we get better UDA or underwater domain awareness, I think we cannot achieve much. Environment and disaster management, I don't think it requires any explanation. More and more strandings are happening. Sustainability is becoming an issue. So how do we build a comprehensive framework? Science and technology, of course, I mean, we have very little understanding of the ecosystem. I don't think we can put so many sensors. So how do we get more data analytics, AI and robotics to make sure that we have enhance our underwater domain awareness? This is the framework we have proposed. Acoustic capacity building has to be a key focus. If you just look at the horizontal construct, all the 4 faces of the cube represent the 4 stakeholders that we just mentioned. The smaller cubes represent the multiple dimensions within these stakeholders. If you look at the vertical construct, a lot of sensing is required. We ourselves have very little understanding of what is going on below the surface of the water, whether it's the river system or the maritime domain. A whole lot of gaps are there in our own understanding. How do we bring application specific analysis and then talk about regulations? Also, there is India has a concern of demographic advantage, or it can become a disadvantage. So more and more career opportunities can be created. I mean, the smaller cube that you see could be the innovations that we can bring in various sectors, and many of them would be cross-cutting across different stakeholders. So, I mean, for a policy framework, I think this cube can sort out a whole lot of things. The prioritizing and the governance whole mechanism can be driven with this kind of a framework. This has been again divided into multiple smaller parts. I mean, underwater radiated noise management is one area. You can see it can be divided into various stakeholders. All the stakeholders, I mean, whether it is a defense requirement or an environmental requirement or even shipbuilding, and I mean, how to reduce noise on board ships is a very, very important area. And a lot more needs to be done. And the tropical conditions have to be kept in mind when we do all this. So this kind of, I mean, the whole larger framework has been divided into smaller parts. Sediment management. I mean, whether it is port management or inland water transport or water resource management, whole lot of areas this can be done. And the same principle applies, and more research needs to be brought in. The user academia industry partnership, this is more suited for the Indian framework. But when we are looking at cooperation, the government has to get involved, or the policymakers have to get involved, and it has to be aligned with the existing policy framework. So I think this works very well. I'll not explain this too much, but a very, very important. I mean, on one side you have the core capacities that are required, or core research areas that are required, and then what are the various policy frameworks that can be aligned to this, and what are the applications, or what are the stakeholders on the fringe. Coastal communities also, there is a lot more that needs to be done. Coastal governance is a very, very big concern. How do we bring more monitoring mechanisms, bring in more technology into data analytics to give you a real-time perspective of what's happening? So that's another big area we're working on. Underwater domain, particularly in the tropical waters, has significant variability, and that needs to be monitored in real time. And our solutions have to take into account the real-time variations. So we've done a lot of work on this. We can just get a sense of what this is. And a complete 3-dimensional picture. I mean, the entire underwater domain has been mapped or needs to be mapped. For the communities, I think snapping shrimp or SHNIM mapping, snapping shrimps are the loudest creatures and one of the loudest creatures underwater, around 200 dB reference 1 micropascal, whereas the blue whale produces 196. And if you look at it in terms of numbers, they are in millions, whereas blue whales are in single digits. So even for submarine deployment, this is a very, very important area. We worked on this, and there are subspecies with very different varying soundscapes. So all that has been mapped. This is one of the work that we have done more specific to the shipping. If you look at ships, you will find that the AIS data has been used to develop the underwater noise. And this won a Global Innovation Challenge in 2019 because this gives you a real-time perspective of how the shipping noise is panning out in the underwater domain. This has multiple applications, whether it is for ecological development or even from a ship designer's perspective, how the different data is being, how different propulsion technology or various technologies are kind of behaving underwater, and particularly in the Indian Ocean or the tropical waters. It can be further used for various other applications also, for monitoring of ships or any dark ships. That is, possibly, some people are trying to do some mischief. They can also be detected using the same method. So there's a comparison of various existing method and how this is better than them. So the digital ocean framework will be very, very important to get a real-time perspective, and any maritime governance has to be led by a digital ocean framework. And there's a lot of work to be done, and I think we will be happy to collaborate with multiple agencies in Russia. I mean, right from communities to various stakeholders, they can. I mean, the value proposition is transparency. I think this doesn't require much of explaining. Everybody understands this. Even for surveillance of underwater threats and all kind of aspects can be looked at, and this becomes more effective in developing countries where all the stakeholders can get benefit and take care of the resources that are required. We have developed a lot of skilling and knowledge-based modules also. Acoustic survey is one of them. It has various applications. I don't need to explain that. Underwater biotechnology, right from pharma to food to various other applications are there. All the modules have been developed and we are running them. Underwater AI and robotics again becomes very, very important, which will require to be kind of taken care. We do a lot of training programs, summer schools. Every summer we have been doing. Last 2 years pandemic has not allowed us to do this, but we get the very, very senior people who come and interact, and also everybody does some project. It's being done at the national level. This year we are trying to, coming year we would like to do it on a regional level. We could partner with anybody who wants to join us. We do a lot of field work as well, going out to the waterfront and doing data collection and then doing analysis. A lot of PhD scholars have worked with us, postgraduate programs. So my last 2 slides would be that this could be led by outreach, engage and sustain model. Outreach is to sensitize people through workshops, seminars and various training programs. Engage is to have certain fellowships where some students and young professionals participate, and sustain is having certain long-term projects in mind where we work together, developing certain technologies. I mean, coming out with policy intervention, technology intervention, and a long-term capacity building initiative. A center of excellence could be a good model where we have these 5 sub-centers: a research center, which is a multidisciplinary research framework; incubation center, where innovation is encouraged; skilling, because a lot of skilling activities are required; academic programs; and then policy center or a strategy center. That's about it. My contact details are available. I would be happy to contact anybody who was interested to collaborate and take things forward together. Thank you very much.
Thank you, Arnab. Thank you very much.
Большое спасибо за очень интересный
Thank you very much for a very interesting presentation. It shows how complicated the system of ocean is and how important it is for engineers while they are preparing. Just they need to know the limits set by the environment for the technical objects that they create. Thank you very much. We need to understand that shipbuilding is not an isolated industry, but the industry that is implemented into the general economy and general politics. Thank you very much. Unfortunately, there is no sound again from the Russian side.
335, мне кажется, стабильнее все.
Вот мы вновь появились на
So
экране.
we are here again on screen. If you can see us, please tell us.
Сергей, пожалуйста. Спасибо большое. Мы переходим
Thank you very much. So we move to the final presentation of our session. The final presentation will be made by the Northern Shipyard. Organization and military equipment. Good afternoon. Can you hear me? Yes. Good afternoon, dear co-chairs and participants of the webinar. Thank you very much for the opportunity to demonstrate and show our enterprise, the Northern Shipyard. I will start the presentation.
Это Андрей Александрович выступает, да?
Да. Королев Андрей Александрович, заместитель главного инженера по подготовке производства.
I'm a deputy engineer for production preparation. Can you see my presentation?
Да, презентация видна, пожалуйста, давайте.
Пока слайды включить не надо, а то... Не надо, не надо.
Слайды сейчас переключаются?
You will see the slides. Can you see it?
Давайте переключать. Что?
Попытка.
Вот так. Переключаются слайды?
Can you see the slides? Can you switch them?
Да, все видно, переключается.
Yes, we can see everything. So the Severnaya Verf, this is former Putilovsky shipyard. First, it was founded as a shipyard for building military vessels. It is located on the land of St. Petersburg in the equatorial of the Gulf of Finland, at the entrance of the seaport. The draft is very comfortable and the logistics is very comfortable, so we can supply all the materials for construction. So an advantageous geographical position, the territory is far from the city center and there are no high buildings. We have very good prospects of developing our technical opportunities for building the ships in the workshops. So since the foundation of the shipyard, we built over 600 different ships and vessels. Here are some rocket, fight ships, and civil ships and vessels and different industrial ships. So today, Severnaya Verf is specializing on building vessels for the Ministry of Defense, for close and remote sea zone, and we also build medium tonnage sea vessels. Our priority for today is the development of the balance civil and military vessels. And now it is 70% of military vessels and 30% of civil vessels, and we want to increase the share of civil ones. So we have all kinds of types of production. We have hull processing production, also pipe processing and wood processing, and also metal processing production. Here is a layout of the technological flows. You can see the red, the hull processing and hull constructing production, also metal rolling. the metal is brought for treatment, and then it goes for welding and assembly works. Here they enlarge, just have larger blocks, and after that enriched blocks go to painting chambers. After that they go for construction areas where formation takes place. This is also the indoor boathouse that helps us to build ships and over 50 tons, and we have also floating dock. After they form the hull from the boathouse by transborder that you can see here on the layout, the size 200 by 130, they put it to the launch position and they put it to the dock, bring it to the dock, and also they have outfitting embankment, the length up to 1,000 meters. And we can place around 10 orders at one time. Of course, the embankments have specific equipment, cranes, that allow us to have outfitting processes on the water. And today, we can process over 20,000 tons of metal. Of course, it depends on the width, on the thickness of metal that is used for building ships. And we can assembly from 10 to 14 orders at the same time. And it also lets us to build 25, 27 orders. Today we do this. For today, the shipyard is loaded, all the capacities are loaded, and we have now 11 orders by the Ministry of Defense and 14 orders for civil shipbuilding and trawlers for different industrial companies, 4 companies, the vessel with a single layer. So these capacities, as I said, are still limited, and according to investment program, we have technical modernization of our premises. What is the investment program? On the slide, we can see 3 stages with the terms of realization from 2016 to 2028 year. For today, we have already implemented several activities. So we have finished the construction of embankment and modernization of equipment. Now we build the covered boathouse, 250 meters by 140 meters with the height of spans up to 70 meters. So the starting positions help us build up to 40 meters and launch mass up to 25,000 tons. The term of realization is 2022. Also, in the first stage, we are going to build the chambers of cleaning, painting. You can see it under the figure 2. Another stage is construction of hydrotechnical infrastructure and systems. They will ensure the operation of covered boathouse and a new dock. This stage includes also the construction of dock itself, up to 180 meters length. The width is 62 meters. So you will have the maximum load capacity 82 tons. We will also make sure that they will have strong basement for loading and for floating. We also are going to ensure all works that will help to roll the metal, and then we are going to build a workshop for cleaning and painting and another chamber to make cleaning, painting, and drying. And the sections will be 25 by 12 by 12. So they will help to make large assembly works and to reduce the time. Another slide, this slide repeats, and you can see that when we introduce another boathouse, we empty the premises of old boathouse for welding and assembly production. So our aim is to increase the productivity of our production capacities. So we have the goal that we cannot stop. We need to keep the momentum. So of course we will ensure some capacities for welding and assembly works. And so we will empty the previous welding and assembly workshop for its modernization. The second stage includes the construction of chambers for cleaning and painting. Also, we are going to transfer the workshop for building into another place, because we are going to modernize the premises. So we will build a totally new workshop. And we will form a storage of components for metal rolling and also for assembling production. And we are going to purchase new equipment. The third stage, we're going to build assembly and welding production with new technology equipment, technological equipment. This is the final stage, and the term of realization is for 2027-28. 2027-2028.
Берега на сегодняшний день действующие берегоукрепления модернизировать причальные набережные, позволяющие.
Seawall reinforcement. We are planning to reinforce the berth up to 600 square meters are to be used for outfitting of the ships and vessels in compliance with the workload. So this slide represents the quantity, composition and quantity of orders depending upon the realization stage, execution stage. The customer and the type of vessel, increase of orders up to execution of the third stage. In general, the productivity shall grow by 2-3 times on different parameters. That's it, general. And the only thing I would like to add is that modernization will allow to build the vessels with a mass up to 25,000 tons, 160 meters length, up to 40 meters width, depending upon the order, upon the type of the ship and vessel. Thank you for your attention. Thank you so much, Andrei. It was a very interesting report. It shows us how efficient is the modernization that is going on in Russian industry. It is even more difficult because in the center of St. Petersburg, there is a lack of space for production facilities, and modernization is to be performed in parallel with the construction of new ships on this dockyard, northern dockyard. Thank you so much. Are there any comments or observations from Indian side? Would you like to add something from dear Indian colleagues before we pass on to the next report, final report of the Shipbuilding Ship Repair Technology Center, Indian side, please? Any comments or questions? If there is nothing to add, then the final speech will be pronounced by Indian side. And now we would like to give the floor to Shipbuilding and Ship Repair Technology Center. Can you hear us? Shipbuilding and Ship Repair Technology Center. Are you going to present? We will contact them. Unfortunately, online video conferences have their advantages and disadvantages. One of the disadvantages is that we cannot see the speaker in person and we cannot quickly arrange the work. Now we are trying to figure out if the next report from SSTC is going to be presented today or not. We just came to know that Shipbuilding and Ship Repair Technology Center will present their speech tomorrow during another session. So from Russian side, I would like to thank all the participants. Thank you for your interesting reports from Russian and Indian side. It was a big honor for us. Thank you so much. And now we would like to give a floor to our Indian colleagues to finalize this session. Mr. Rakesh Bajaj. Mr. Rakesh Bajaj, the floor is yours for finalizing words.
Now we call upon Rear Admiral Rakesh Bajaj for his comment on the whole session.
Thank you. It was a really well conducted seminar. I must give congratulations to the event managers. The first paper on integrated ship electrical propulsion system. This has been at the heart of Indian Navy for quite some time. I, for once, have served on electrical propelled ship INS Amba, which was a submarine mothership. It was a pleasure serving on such a silent ship. Indian Navy has had two electrical propulsion ships. One was INS Jamna, which was a survey ship, followed by INS Amba, which was a submarine mothership. The next paper presented by Jetu Sukumar Nair was a real frontier in technology. Only question I have from him is, why did they color the ship red?
Yes, sir. Do you want me to answer that question?
Yeah, it'll be nice.
Yes, sir. So I used to be GM shipbuilding of an oil and gas service company called Ultra Deep. and we were building 6 diving vessels, so SAT diving vessels, and all the ships were fully red in color. So it was completely red, including the superstructure as well as the hull. So when I started doing this project, so we were trying different colors, but then red was a very unique color, which was like outstanding. So that's why red.
Any advantage on the marine platform to be red?
No, sir. Actually, it's really expensive. Otherwise, there is no much. I mean, the paint is special, new, latest technology paints. Otherwise, painting red, there is nothing beneficial.
Okay, thank you, Jetu. Well done. It's an excellent project you conducted.
Thank you very much.
Yeah, and Commander Arnab Das is doing real frontier work. He has been a blessing to Indian Navy and the maritime structure for this country, and I'm sure with his active participation, he will continue to guide the maritime domain awareness project which he's taken upon himself. I wish him all the best in the years to come. The other 2 papers were in Russian, and I promised the organizers that I'll try to learn some Russian before I sit in the next year. Thank you very much. All the best.
Были на русском, что переводчики не работали на что? Так, ну что тогда, да? So, if you don't mind, and my Indian colleagues, first of all, I think it has been stated. Нет, я по-русски буду говорить, извините. Значит, если вы не возражаете, я
If you
тоже...
don't mind, I will say a few words as well, a couple of words. It seems to me that the sessions that we've been listening to were exclusively interesting and full of innovative solutions, interconnected topics, such as Research Center of India report, as Oleg Timofeev mentioned. A general picture of marine engineering solutions was presented in that report.
Эту тему продолжим, она связана...
This topic we will continue working in this direction, the blue economic. We are going to have a special session guided by Professor Raju. It seems to me that co-chairman worked efficiently, and as for the first session, this was Vice Admiral Deshpande. We would like to thank him, Mr. Vladimir Alexandrov. For the second session, a great Commander Hemant Khatri. Thank you for your work. And from Russian side, Valery Kiriev, Deputy Rector of the represented Shipbuilding Ship Repair Technology Center. Session number 3, co-chairman Oleg Timofeev and Rakesh Bajaj, Rear Admiral. These were very interesting reports. Different aspects of our industry were covered. And I hope that tomorrow's session that starts tomorrow, Indian time 11, and Moscow time 8:30, we start our session. I hope that tomorrow's session will be as interesting as today. The Industry 4.0 is the topic of tomorrow's discussion. Modern outfitting, shipbuilding and shipping. There was a wonderful congress arranged in 2019 in New Delhi, where the representatives of the industry of Indian Navy showed a very interesting application of new technologies, digital twins and virtual integration, big data. From this sphere, tomorrow, we are going to listen to the reports. No sound again. The translation is not possible because there is no sound. The interpreting is not possible.
Professor Kirill?
Again, technical issue. There is no sound from Russian side, unfortunately. I think we need to wait until they will reload the system.
Okay. So, Dr. Arnab Das?
Yes, sir.
Good to see you on the screen.
Thank you so much, sir. Thank you for inviting, sir. Thank you very much.
No, it is our pleasure, sir, having you.
Thank you, sir.
We are thankful to you for being with us.
No, sir, such an invite is always nice.
Thank you, dear colleagues. Tomorrow we are going to listen to another interesting report dedicated to repair and technical maintenance and operation. A very interesting session where Zvezdochka company from Severodvinsk is going to participate, and the report of Commodore Deshmukh dedicated to MRO equipment. Blue economics is going to be discussed by Mr. Professor Raju and Professor Goncharov, and we will finalize with the university cooperation, which is spreading and developing between Russian and Indian universities. And we have decided to listen to the reports of the assistant professors, and the closing session where Vice Admiral Deshpande will speak and Professor Shudamadyan Raju will speak. And we will thank all the participants. Thank you very much. And we see you tomorrow, 11 Indian time and 8:30 Russian, Moscow time. Thank you so much. Thank you. See you tomorrow.
Thank you.
Thank you. Thank you all.
Thank you.
Okay.
Thank you. Thank you very much.